velocity is equal to the rate of change of momentum. Ha! By now, I think you know the answer. So guys, they say the rate is always about what? The time. And the change in momentum, we know this is what? Change in P. Again, we know that momentum, this is what? Momentum, the formula for momentum, this is what? The product of mass and velocity of what? Of an object. So now, when you introduce the change in momentum, look what's happening. When you introduce the change in momentum, what is happening to your velocity? The velocity also what? Changes. Understand? So change in momentum affect what? Change in velocity. And change in velocity affect what? Change or affect momentum, which will result in what? In change in momentum. So now they are asking us for the physical quantity, which is what? Which is equal to the rate of change of momentum. I'll start by introducing you to Eastern second law, which is what? The Newton's second law. Newton's second law. Sorry about that. Newton's second law, which is what? F net. Remember F net, which is equals to ma. So now we know that, guys, acceleration, this is what? Change in velocity all over what? Change in time. So now let's substitute this into what? This formula here, the Newton's second law. This is the Newton's second law, guys. So F net, which is the force, will be what? Will be the mass, and in a place of the acceleration there, we'll put what? Change in velocity all over change in time. So now you have all over 1 there. When you multiply the numerator and the denominator there, you'll have what? You'll have m change in velocity all over what? All over change in time. But if you are to check here, your numerator, that's change in velocity. Mass changing, of course, guys, mass is a constant there. Mass doesn't change. So you have what? Mass and change in velocity. What's that? The numerator will give you what? The change in momentum. So now, if we make the substitution, it means now we'll have what? We'll have change in momentum all over what? Change in time. So what is this, guys? What is this? This is what? The rate I told you is all about what? Time. You can see we have time here. And then what? Change in momentum. This is the change in momentum in your numerator there. So now the rate of what? Of change in momentum, this part, this is what? This everything here in red, guys, this is called what? The rate of change of what? Of momentum. So now look, the rate of change of momentum is equal to what? Is equal to this part here, which is what? The force. It's equal to what? The force. So it means now your answer will be what? Would be C. Which physical quantity is equal to the rate of change of momentum? This is the rate of change of what? Of momentum, which is equal to what? The force. So the answer is what? Is C, which is the force. I hope that was clear, guys. Now, so I hope I'm clarifying here. So now, guys, let's take a look at 1.2. Of course, guys, we're gonna spend time here. So let's see. Let me just stick to red. So now 1.2, they say, okay, let me just take this up. They say that the gravitational acceleration on the surface of a planet of a radius r is what? Is g. The gravitational acceleration on the surface of a planet of a radius r is g. So now they are saying the gravitational acceleration at a height of what? So let me just highlight this. So this is the surface, and the radius is what? Is r. And then, let me just put this r there. And then number 2, we have the height, and then of what? Of 2r above what? The surface of the same planet. So they're saying is, meaning they are looking for the answer there. So guys, we need to give we need a formula, guys. You know this formula. Look what's happening there. You know this formula, that gravitational acceleration, this is what? The universal gravitational force multiplied by what? The mass all over what? R squared. Let me show you this formula. Let me show you this formula. So let me pause and show you this formula. So now, this is the formula that I'm talking about, guys. You can see this formula, it is given. So now, I'm using what? The formula sheet, guys. You see? So this is at the table. You come here for the forces. Yeah? You come here for what? For the forces. You use this formula. Yeah? So we are using this formula, which is what? The G. Look what's happening there. Which is the G. And then what? And the G here, it is this one here. This G, it is what? The universal gravitational constant. And this is the acceleration due to gravity. So now let's go back to the question there. Okay, so remember, this G is what? Is the gravitational acceleration. Gravitational acceleration at a height. Gravitational acceleration. This is the reason why I use this formula, guys. So make sure you know the concept very well. And of course, I'm clarifying everything here. So this is the gravitational acceleration. So they are saying that the gravitational acceleration on a surface of a planet of a radius is what? Is r. So now it means we're just gonna substitute here in the place of what? Of this radius with what? With r. So now let's make the substitution. So we're just gonna say this is what? This is going to give us g m all over what? All over r squared. So this is what we have. So now they're saying what? The gravitational acceleration at a height of 2r, at a height of 2r. So guys, I don't know how am I supposed to like picture this for you, but let me try. Let's say that you have a planet like this. A planet, guys, I know this, a planet is a cycle, has a shape of a cycle. So now, let's say that this is the radius of what? Of a planet. The radius of a planet. So I just wanna like picture this for you. So the radius of a planet is given by what? By r. So now we have the height. We have what? The height. So if we have the height like that, so I'm just gonna connect there and make what? A triangle. So it means now the height is gonna be what? 2r. We're given that's 2r. So now to find this part here, this is what? This is what is going to give us what? The radius there. It is going to give us what? The radius. So this is the radius there. That part is what? The radius. Let me call it small r, guys. Is this what? The radius of what? Of the planet. We're talking about what? The planet. So it means now we need another formula. The same formula, because now they're talking about what? Gravitational acceleration. So now I'm just going to say this is what? Initially. This is what? Initially. So now G final here, it is going to be what? G final, we're also going to use the same formula. But remember, to find the radius, which is the hypotenuse, using what? What is this? The Pythagoras theorem. You know, when you use Pythagoras theorem, you say what? R squared, which is equal to what? X squared plus Y squared. In this case, this is going to be your X, your Y, your R. But now, guys, let's forget about what? The r squared, those r squares there. Let's forget about those r squared and write r is equal to what? X plus y. So it means if we are to say r is equal to x plus y, so now we are looking for what? For the r nu, the radius nu. So the radius nu, so I'm just going to say the radius nu is gonna be what? Is gonna be the x, which is what? The r, which is the radius of a planet, plus what? The height of a planet, which is what? 2r. So it means r nu is going to give us what? R plus 2r, this is going to give us 3r. So it means now the gravitational acceleration of this height and above all, the gravitational acceleration of 2r above the surface of the same planet is going to be what? So I'm just going to say G surface, guys. I hope you understand this. So I'm just going to say G surface is going to be what? Gm all over what? The radius now, it is what? Is 3r. So I'm just going to say 3r and then what? Squared like that. So the answer is going to give us what? It's going to give us Gm all over what? 3 squared, that's 9. R squared, that's what? R squared. We know we can write this as what? As 1 all over 9 times what? Gm all over what? All over R squared. This is the same thing. When you multiply the numerator and the denominator, you're just gonna get the same thing there. So, but remember, guys, remember. Look at here. What is this? Isn't this the same as what you have here? Isn't this the same as what you have there? It is the same thing. So we can make the substitution there. Now, forget about the G initial. That was just the naming, guys, so that you understand. Now, so it means now, excuse, the gravitational acceleration at a height of 2r above the surface of the same planet is going to be what? It's going to be G, which is equals to what? Which is equals to 1 all over 9 multiplied by what? Multiplied by this G here, because this G is the same as Gm all over R squared, which is Gm all over R squared. So you're just gonna put what? G there. So your answer will be what? Will be G all over 9. So if you have to check here, where's G over 9? This is G over 9. So your answer is what there? Is A. So you get those what? 2 marks. So we have 2 marks. And let's not forget here, we have what? 2 marks. So now let's move to the next question. I told you guys we are just going to spend a lot of time here because those 2 marks ain't going to come anyway, guys, without doing the calculations. You don't just guess. So now, 1.3, guys. A ball falls from the edge of a table. Ignore the effects of air friction. Once we ignore the effects of air friction, it means now this is what? This is an isolated, guys, always remember, this is an isolated what? System. We are talking about what now? An isolated system. Once we ignore the effect of air friction, now we're talking about what? An isolated system. They see that which one of the physical quantity associated with the ball during the fall remain constant, which is what? Not changing, guys. Constant means what? Not changing. Is it A, the weight? Is it B, the momentum? Is it C, the kinetic energy? It is D. Is it the D, which is the gravitational potential energy? We need to find out. So remember, what is weight? Weight, this is the same as what? As mg. This is the mass multiplied by what? By gravity. Gravitational acceleration, which is what? Known as 9.8. It doesn't change this one, guys. And the mass is not going to change, guys. It's always going to remain the same because this is an isolated system. Yeah? So the weight, the mass is not going to change. Gravitational acceleration is not going to change. But now it seems like we already got the answer. But wait, momentum is what? Momentum, we know momentum is what? Is P, small p, small p, which is what? Mass multiplied by what? Velocity. All right. Mass multiplied by what? Velocity. I'm just going to come back here. What is kinetic energy? We know kinetic energy, this is EK, which is also known as what? Half, or which is also equals to what? Half mass multiplied by what? Velocity squared. What is gravitational potential energy? This is EP, which is what? Gravitational potential energy, which is what? mgh. The mass, gravitational acceleration, and what? And the height. They are telling you that a ball falls. It means now it falls from what? The edge of the table. So let's say that this is what? The table here. This is your table. You have what? You have a ball. You have a ball like that. If it falls down like that, what happens to the velocity? If it falls, initially, V initial is what? 0 meters per second. What is the height? If it falls from there up to this point, the height is going to be this one. This is what? The height. So what happened when the ball is at what? The table there, or at the edge of a table? The height now is what? We have when the ball is at the edge of the table, we have what? We have EP, but once it hit the ground, now the gravitational potential energy is converted to what? To kinetic energy, meaning we are losing the height. When it reaches this point here, let's say this is A and then this is B. When it reach point B, the height is going to be what? 0 meters. But at this point, the height, let's say, is gonna be what? 3 meters, guys. And the velocity here is not gonna be the same as the one it started with at point A. The velocity is gonna change and it's gonna increase since it started by what? Falling. So let's say the V final is gonna be like let's say 9 meters per second. You see, the velocity is changing. So once I told you that once the velocity changes, what happens to momentum? Momentum does what? It changes also. Now the velocity changes. Now, when the velocity changes, the kinetic energy is what? Is gonna change. So now the answer is not gonna be this, the answer is not gonna be this, because these are not remaining the same. And this is not gonna be the answer because at the edge of the table, from point A to point B, we are converting from potential energy to kinetic energy because now the height here, remember these are constant. Your M and the G are constant, but the height at point B is going to be 0, meaning it is changing. I told you that this is an isolated system when they say ignore air friction. This is an isolated system. It means now the energy before is equals to what? The energy final. Yeah? But this is not conserved since something is changing there. So it means now our answer is going to be what? A. Understand? So that's the weight. Now we got what? Those 2 marks. Let's move to the next question. I told you we're going to do a lot here. So now, 1.4. They say that we have 2 trolleys X and Y of a masses M. Let me just highlight that of a masses M and 2M there. Excuse, respectively, are held together by a compressed string between them. Initially, remember that initially they are what? They are stationary. What happens when something is stationary? When something is stationary, we know the velocity is what? The velocity is 0 meters per second. Now, it is what? It is stationary. The velocity is what? Is 0 meters per second. And then they say that on a horizontal floor, as shown in the as shown below, ignore effect of friction. What have I told you? Told you that once they say ignore the effects of friction, now they're telling you that this is an isolated system. So remember, isolated system, this is what? The system where the net or the resultant or net external force is what? Is 0. Example, the net external force we're talking about if friction, and in this case it is ignored. In this case, since it is ignored, so now this is what? Isolated system. So it means now sum of our things before is to equals to what? Sum of our things after. We're gonna check what is that. They say that the spring is now released and it falls to the floor while the trolley moves apart. So now, once the string is released, we know that this is going to go to what? Or head to what? To the west, and then this to what? To the east. So now, they say the magnitude of the momentum. You see, now we found out what? Our component. We're talking about what? Momentum. So since this is an isolated system, what do you know about momentum? Since it is an isolated system, momentum before collision is equals to what? Momentum after what? Collision. So since initially they were stationary, they had the same velocity. They were sharing what? The same mass. We're just gonna add the mass of what? Of X plus the mass of what? Of Y. They have the same velocity there, V initial. They were stationary, all of them. So initially they had what? A 0 velocity there, 0. So it means now everything is gonna be 0 this side initial. So this is equal to what? Sum of momentum after. So it means this is 0 is equal to what? Sum of momentum after. This is the combination of what? Of X and Y. So it means now this is the momentum of X plus the momentum of what? Of Y. When we solve this, it means now take this, let me just say, take this to what? To your left. It means now you'll have what? You'll have negative you'll have negative py, which is equals to what? Px. So now they're asking the magnitude of the momentum of the trolley X while it moves away. So let's check the answers. You see, this is our answer here already. The momentum of the two trolley has to be the same initially and after. Yeah? But in the opposite direction, you can see that this is going to the west, this is going to what? To the east. But they have the same momentum since this is an isolated system. So nothing changes. But they are just going to point in different what? Direction. So if you have to check, the answer is not going to be zero there. They're saying that the momentum, the magnitude of the momentum is going to be what? Half the magnitude of the momentum. That's wrong. Twice what? That's wrong. So the answer, if you have to check, the same as the magnitude of the momentum of what? Of trolley Y. So the magnitude of the momentum of trolley X is going to be the same as the magnitude of the momentum of what? Of trolley Y. So your answer there, guys, is going to be what? D. So you get what? Those 2 marks. You understand? You get what? Those 2 marks there. So let me take nice there. So you have those 2 marks. Let's take a look at the next question. An object is dropped from rest. We know something about an object being dropped. When they say it is dropped from rest, it means now V initially the velocity is what? Is 0 meters per second. Now, and after falling a distance x, okay, let's highlight that. Distance what? X. Its momentum is p. All right, its momentum is what? Is p. Now, this was initial, guys. Now after, this is after here. This is your after. They are telling you that the momentum of the object after it, you see, after it has fallen, the distance is what? Is 2x. They are saying is, so they're looking for the answer. So they're saying the momentum of the object after it has fallen a distance to x is what? I'm going to show you how. Yeah. So now we know that since we are dealing with momentum, guys, what is momentum? Momentum is the product of mass and velocity of what? Of an object. Or let me just write this nice. This is momentum, small p is mass multiplied by what? Velocity of an object. We are talking about an object being drawn. So it means it is starting from a certain height and then it's gonna fall to this to the ground like that. So now, what are you thinking about when you see an object starting from the top and then it falls to the bottom? You are thinking about what? The vertical projectile motion. Yeah? You're thinking about what? Projectile. So it means we're just going to apply the principle or the equations of motions, yeah? Which is what? Vertical projectile. So remember, the equations of motion, I'm just going to write them down here. So this is Vf, which is equals to what? V initial plus 2, A changing Y. Is it changing Y? Let me see, Vf is equals to V initial plus, I think it's A changing T. This is equation number 1, guys. See, I still remember them. And then number 2, I think this is Vf is equals to V initial squared plus 2A changing Y. And then equation number 3 is going to be changing Y, which is equals to V initial changing T plus a half A changing T. Guys, I know them by heart. Trust me, I know them by heart. So now, which equation are we going to use? We know we have the change in Y, but we don't have the change in T. So you're not going to take these ones here. We're just going to take what? Equation number 2. So now, taking equation number 2, look what I have here. I have Vf squared, which is equals to what? V initial squared plus 2A changing what? In Y. Now, so now, what do we know initially? The ball was dropped from rest. It means now the velocity initially is what? Is 0. So it's going to cancel out this one. It's going to fall off. So it means what you have now, guys, you have this equation here. You have Vf squared, which is equals to what? This part. But what is change in Y initially? Change in Y initially, the distance is what? Is X. So it means Vf squared is going to be what? It's going to be 2. What? But what about the acceleration? We know acceleration is the same as what? It's the same as gravitational what? Acceleration, which is what? 9.8 meters per second. And then to the power negative 2 there. So this is going to be what? G into that. What is the distance? Is what? Is x. So to find the VF, you're just going to square both sides like that. Let me introduce red. So you square both sides like that. It means now, therefore, V is simply what? Is simply the square root of what? Of 2gx. Let's leave it there. So now let me see which color to use. So now, guys, let's come back here. They say again the momentum of an object after. Yeah? After what? After it has fallen the distance 2x. So we're just going to use the same equation, but in this case, the distance is what? Is 2x. Understand? The distance in this case is what? Is 2x. So the same formula, Vf squared is equals to what? 2a is what? Is the acceleration which is known as what? The gravitational acceleration there. But in this case, the distance is what? Is simply 2x. Don't multiply, guys. Don't rush. In math or physics, we don't rush when we are doing the calculation. You relax. Understand? You relax. So square both sides. When you square both sides like this, you see you have V, F, or I can call this V initial. This is gonna be what? This is gonna be you can simply square the 2 and then multiply by the square root of what? Of the G, or 2gx. Why am I saying this? Why am I taking the factor now? Because I see something here that we can write this, what we have here, the same as what we have before that. You understand? So follow the steps. So it means now you're just going to say what? We are just going to say, therefore, the V here is going to be what? It's going to be the root of 2 times what? Times the root of 2gx. But remember, we are also introducing momentum here. What is momentum? Momentum is the product of what? Of mass and velocity. Yeah? So momentum is that, the mass is that, velocity of this part here is what? It is simply root of what? Of 2gx. Now, let's get into this part here. This part here, I can call momentum prime, meaning momentum after. So it's just going to be what? It's just going to be m into what? Into the velocity here is what we have here, which is going to give us what? The root of m times what? The root of 2gx into that. You understand? So now we're just going to say, okay, let's multiply. So p prime is going to be what? It's going to be the m root 2, or let me just say like this. Let me just write it like this: 2 root m times what? Times m into, let me change the color so that you can see something here, into m and then root of what? Of 2gx. So remember, when we multiply here, you have what? You have m into root of what? Of 2gx. Isn't this the same as what we have here? It is the same, guys. So it means now the p prime, the momentum of object after is going to be what? Is going to be the root of 2 multiplied by what? Multiplied by momentum. So your answer here when you check is what? Is simply B. Remember, we're using red here. So it's simply what? Is simply B. So your answer is what? Is root into what? Into P there. It's root of momentum. So you get those 2 marks and we are done. So now let's take a look at the next question. A police car with its siren. I'm just going to picture this for you. I'm just going to picture this for you guys. I'm just going to picture this for you. So you have a police car like this with its siren on. Pew, 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 pew. You understand? Pew, pew. So let's say it is, let's say it is traveling at a constant speed. What do you know when something is traveling at a constant speed? It means now the speed initially is the same as what is the speed final. So nothing is changing with the speed there. So towards a stationary sound detector. So let's say that we have a detector here. Let's call this the detector like that. We have a detector like that. Now we have what? A detector. We know that since this is Doppler, guys. This is what? Doppler effect. Once you hear about the police car with what siren on, what, this is Doppler effect. So it means now it is sending the waves, the wave when it is approaching. Now the wavelength are what? Are shorter, guys. But where it comes from, the wavelength are longer. Understand? And this guy here is gonna detect a higher frequency than the perceived one. So it tells us now that the frequency, we can call this one the source, not the source. This is supposed to be the listener, guys. This is the what? The listener. I hope the spelling is correct. And then this is what? The source. So the frequency of the source and the frequency of the listener. The frequency of the source is going to be less than the frequency of what? Of the listener. In other words, I'm saying that the frequency of the listener is going to be greater than the emitted one. You understand? So now let's check which one of the following combination best describe the frequency. Remember, the speed is not changing. Yeah? The frequency, is it less than f? Remember, this guy is moving towards, when it is moving towards the frequency, this detector is gonna detect a higher frequency. Let's say the frequency that was emitted is 500 Hz. It means that the perceived one is gonna be what? Is gonna be higher than this one, maybe 550 Hz. So now they're saying, is it less than? The answer here is wrong. Is it less than f? The answer is wrong. Is it greater than f? Here we start suspecting. Greater than what? Less than f. The speed is not changing, remember? So this one is not gonna be our answer. So, but if you are to check here, they say greater than f. We are talking about what now? We are talking about the frequency and the speed detected by what? By our partner here, which is what? The detector. So it means now the frequency is gonna be what? Higher than the emitted one. So our answer is D, greater than. And the speed is not what? Changing. So our answer is D there. We got those full 2 marks. Let's take a look at the next question. I hope you're enjoying, guys. You might find that we are not recording. So now, guys, 1.7. They say that you have 2 identical spheres, R and S, on an insulated on an insulated stand, carrying charges of positive Q, negative Q, respectively, are placed at a distance apart. Sphere R exerts an electrostatic force of magnitude F on what? Sphere S. We have to what? Determine that thing before we read what we have here after this statement. We have to deal with this first statement, guys. Remember, if we have electrostatic force, when you have 2 charges next to each other, according to Coulomb's law, they are going to what? Experience a force. And what is that force? How can we calculate that force? We calculate that force by using what? This formula F is equal to what? K, which is the constant K multiplied by what? Our charges Q1 times Q2. You know these formulas. Do I have to show you? Okay, let me show you. If you have to check here, guys, this is electrostatics. Now, this is the formula that I wrote there. This is the formula that we are going to use. Oh, you're not seeing now. This is the formula. Yeah? This is the electrostatic force. This is the constant Q. These are our charges that are next to each other. And the R is the distance between what? The 2 charges. So that's the formula. Yeah? So nothing is too expensive here. Let's go back there. We are back. So now, this is what the F, which is what the electrostatic force. They are saying that sphere R exerts an electrostatic force of a magnitude F on sphere S. So let's determine let's determine that force. So we know that since these charges, you have Q1 and the Q2, they are identical. Yeah. So since they are identical, guys, we are just good. Now you also learn about something called the absolute value. Yeah? The absolute value is something like this. If you have a negative x, you can put this inside the absolute value. It's going to give you what? X. When you have a negative 1, the absolute value of a negative 1 is going to give you what? A positive 1. The absolute value of a negative 9 is going to give you what? 9. I hope you're understanding how absolute value works. Understand? So I'm just gonna use this thing here. So now look what you have. This is K. You don't have to substitute these values. And then our charges is what? Is Q there plus Q. And then multiply by what? Multiply by negative Q all over what? All over R squared. So now therefore F is gonna be what? Is gonna be K into what? Q times Q, but with a negative sign, you'll have what? Negative Q squared. So this is the reason why I introduce absolute value. So I have a negative Q and then squared like that. All over what? All over R squared. So now, what is the absolute value of a negative number? The absolute value of a negative number is what? Is a positive value there. So therefore, the force is just going to be what? K multiplied by what? Multiplied by Q squared all over what? All over R squared. So now, this is the what? The force. So now let's read the next question. They're saying that the two spheres are now brought into contact. They are what are brought into contact and return to their original positions. The magnitude of the electrostatic force that the sphere R exerts on sphere S is now what? They are asking you, is now what? So now that's very simple, guys. So now when two charges are next to each other, you know they will experience a force according to Coulomb's law. Then what? They will feel what? A force. So since you are dealing with two identical charges or two identical spheres, when you brought them into contact, they are going to what? Their charges is going to be distributed equally. Understand? The charge is going to be what? Distributed equal. So it means now the first thing that we have to do is what? Is to find the Q total. To find what? The Q total. To find the Q total, this is very simple. You're just gonna say, okay, the Q total is just what? The charge or the charge of what? Of R plus the charge of what? Of S. So this is the same as what? The charge of R is what? Is positive Q. The charge of S is what? Is simply negative Q. These are going to rationalize. So it means now the Q total is simply what? Is simply 0. Then it is what? It is simply 0. So now, to calculate their charges now, this is the formula. To calculate their charges now, you're just going to say, okay, their charges, you're just going to say, okay, charge is simply what? Is simply Q total. Then divided by what? By 2 there. So this is going to give you what? 0 divided by 2. This is just going to give you what? This is going to give you 0. So now we are just going to use this formula here to calculate what? The electrostatic force, the new electrostatic what? Force. Again, this is the initial electrostatic force. Now, this is what? The initial electrostatic this is the initial electrostatic force. Now, this is what the one that we have to determine now. So it means their charges now. They what? They has to be the same. This is what they are identical. So Q, what? QR is to what? Equals to what? QS, which is the same as what? As 0 there. So it means now F is going to be what? Is going to be K into what? Into remember, using this formula, we have to multiply. But in this case, their charges is what? Is 0. So 0 multiplied by 0 all over R squared. This is going to give us what there? This is going to give us what? The absolute value of 0. That will give you what? 0 all over R squared. Therefore, the force is going to be what? This, everything there is going to be 0. So this is 0 Newton there. It's going to be what? 0 Newton. Yeah? So this is our answer, guys. This is what? Our answer, 0. This is your answer there. I hope you understand. When you bring two charges or or two identical spheres, they are going to what? Or they are going to, or they will have the charges, or their charges are going to be distributed equally since they are what? They are identical. So you calculate the Q total. After calculating the Q total, you have to find what? Their new charges since they are brought into contact. And then after now you have to calculate when they return to what? To their original position, because now their charges might have changed. So to calculate that the Q nu, since you know that this is a two identical spheres, it means now the QR and the QX are the same. So Q total divided by 2 is going to give you what? Their new charges, which is what? 0 there. Understand? 0. So it is 0 at Q log. So when you substitute there, you're just going to get what? 0. So the electrostatics force is just what? 0 there. They cancel each other. So this is what? Your answer, guys. So you get what? Remember, we're dealing with red here. So this is what? Your answer. 2 marks. So now, next question. Write down which one of the graphs below best represent the relationship between the potential difference and the current for an ohmic conductor. Guys, you know something about electricity or electrical circuits? There is this thing that obeys Ohm's law. There is that one that obeys what? Obeys Ohm's law, or Ohm's law. The one that obeys Ohm's law is what is called the ohmic conductor. Yeah? The one that obeys Ohm's law is called what? The ohmic conductor. The one that does not obey Ohm's law is called what? A non-ohmic conductor. So using this small triangle, you know that you have a current, and then you have what? You have a resistor and then a voltage. So if you have to check, the voltage is equal to what? I multiplied by R. Telling you now the voltage is proportional to what? To the current in the conductor. You know the definition of what is this? Of is it Ohm's law, or is it Ohm's law, or I think it's Ohm's law. It says that the potential difference across a conductor is directly proportional to the current in the conductor, provided that the temperature remain constant. So if you have to check here, we have a linear relationship. When this increases, this is going to be what? Is going to increase. So if you have to check here, is A gonna be our answer? Nope. Because you can see the voltage is what is constant there, it's not changing. Is C gonna be our answer? No, because this one, when this one increases, or this one, when this one increases, this one what? Decreases. So that's not ohmic conductor. Is this gonna be our answer? Nope. Because when this one decreases, this one what? Increases. It's not gonna be what? Our answer there. So our answer is what? Is B, because there is a linear relationship. This is what? Ohmic conductor. The voltage and the current, they are directly proportional. When the current increases, you can see when the current increases, what happened to your voltage? Your voltage also what? Increases like that. It also what? Increases. So our answer is what? Is B there. So now, next question. Which one of the following combination regarding the energy conversion in the electric motor and electric generator? Guys, this is called the electrodynamics. Yeah? The what? The electrodynamics, guys. So now they're saying which one of the following combination regarding the energy conversion in the electric motor and the electric generator is correct? Yeah? Electric what? Motor and electric generator. Remember, when you are dealing with what is this? Electric motor. Electric motor, we have to do what? We have to convert electrical energy into what? Into mechanical energy there. So if you have to check 1.9, is A gonna be our answer, mechanical energy to electrical energy? The answer is wrong, because A here we are talking about what? We are talking about this thing. What is this? It is remember there is a motor and a generator. There is a motor and a generator. A motor, guys, a motor and a generator. Remember, a generator makes what? Generator convert mechanical to what? To electricity. That a motor does what? Convert electrical to what? To mechanic. Understand? So if you have to check here, mechanic, electrical to electrical, the answer is no. This one, nope. So the answer is what? Is D, because we are starting from what? electricity to what? To mechanical. It's like a battery, guys. You see a battery of a car, it converts what? Electricity to mechanical. Mechanical is all about what? Movement. Yeah? So when you produce electricity, there will be what? Movement. So your answer there is gonna be what? D. So that's your answer there, guys. Because you're talking about what? The motors. Yeah? You're talking about what? The motors. The motors here convert electrical to mechanical, and the generator convert what? Mechanical to what? To electrical. So the answer is correct. This one I didn't read this part, but it's still correct because when you're talking about the motor, you're starting from what? Electricity to mechanical. A generator, guys, think of generator when there is electricity or electricity shutdown or load shedding. When you use a generator, you want to convert what? You want to convert from mechanical to what? To electricity. You want to have what? Electricity. So what? That's what the generator, guys. So your answer is D there. So now let's say 1.10. Consider the statement below regarding the photoelectric effect. So now this part is called what? Photoelectric effect. One of the wonderful chapters. Now, they're saying that, remember, a photoelectric effect, this is the process whereby electrons are ejected from the metal surface when the light of suitable frequency is incident on that what? Surface. So if you have to check here, the photoelectric effect proves that they're looking for the answer. It proves that light is quantized. Light has a particle nature. Light has a wave nature. What do you think about this? Before I start answering, what do you think about this? Remember that photoelectric effect, this is what? The particles nature of light. It is what? Particles nature of light. So already we have this answer. So what about these two? Now, this one here is not going to be the answer here. Because now we're starting to talk about what? The wave nature. We're talking about what? The wave nature, but photoelectric effect, we are talking about it proves about what? The light has a particle nature. It is what? A particle nature, quantum energy. So now, if you have to check, light is quantized. What's the meaning of that? It means now the energy of a photon of an incident has to be what? Has to be greater than what? The work function. Once this is true, light energy is what? Is quantized, meaning that the energy of a photon is greater than what? The work function. What is work function? Remember, work function, this is what? The minimum energy required to what? To emit electrons from what? From the certain metal surface. Understand? So once the energy of a photon is greater than the work function, now the electrons will what? What is this? Will be ejected from what? The metal surface. So this is the energy of a photon. So your answer there is this 1 and 2, Roman figure 1 and Roman figure 2. So let's check Roman figure 1 and Roman figure 2. So the answer is what? Is C there. So this is what you answer, and we got that 20 marks. So take out your calculator and say 20 all over 150 times 100% and see what we have there. So now, guys, this is Newton's law. Yeah? This is what? Newton's laws. We're dealing about what? Newton's laws. So let's take a look at this. So now, they are telling us now that the block, I don't know if you are seeing this color, let me just change it to this. So now they're saying that the block P of a mass 2 kg is connected to block Q. So let me make sure that you're seeing this, guys. Now, we have P and Q, they're connected. They're connected together, and then you're told that Q of a mass 3 kg, okay, we can see that, and then they're connected by a light insensible what? String. Both blocks are on a plane incline at the angle of what? Of 30. You can see they're inclined at the angle of what? Of 30 degree there. So now to the horizontal, block Q is pulled at a constant force of what? Of 40 newtons there. And then at the angle of what? Of 25 to the incline. And then block P moves on a rough. Wow. Wow, 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 wow. Okay, it means now there is friction. We know once you hear rough, yeah, we have what? We have friction. Hey, let me just write it down. We have friction now. Friction is present here. So there is friction between point A and B. Yeah? So they say Y block Q moves on a frictionless. Okay, meaning frictionless, there is no friction there. That BC there. So now, guys, enough with the talking, guys. Let's just get into the questions. You'll always see this first question here. Now, once they tell you that they say state Newton's second law, what's in your mind when you think of Newton's second law? Newton's second law. This is just the first what? The force and the what? And the mass multiplied by what? Acceleration. This is the Newton second law. It is what? It is his new is a law which is called what? The Newton second law. Newton is a name, guys, and then a law. This is what F net is equals to ma. So this is Newton's second law. So they're saying state Newton's second law. Newton's second law, remember, is state that when a net force or a resultant force acts on an object, the object will accelerate in the direction of what? Of the force. And the acceleration is what? Is directly proportional to what? To the force, and inversely proportional to what? To the mass of an object. Let me bring this using what? This formula here. Let's derive this using the formula. Let's derive the definition of Newton's using what? The formula. The force is equals to what? The force, remember, this is what is equals to the force. If you have to check there, is equals to ma. When you divide both sides by m all over m, this and this rationalize. So therefore, f all over m is what? Is equals to a. This tells you that acceleration is directly proportional to the force. Number two, this is number one. This is number one. Number two, this is how you remember your definition, guys. Me, I don't memorize definitions. Né? So now, number two, acceleration is inversely proportional. Inversely meaning there is a fraction. It's inversely proportional to what? To the mass of what? Of an object. So now let's read that definition. Remember, it says if and when the object or when the net force or when the what is this when the net force acts on an object, the object will accelerate in the direction of the force. But what happened to that acceleration? This acceleration is what? Is directly proportional to what? To the force. And what? And inversely proportional to what? To the mass of an object. That's the definition, guys. I don't need to write it down, guys. So now they say that, okay, they told us about something here. They say that an average constant frictional force of 2.5 Newton acts on block P as it moves from A to B up the incline. Okay, so you have friction there. So now they say that we have to this is I jumped to this one. They say that we have to draw a labeled free body diagram of what? For the block P. So for block P, guys, if you have to check, we have what? I don't know if you can see this. Let me just use let's see. Let me use this one. So if you have to check there, you'll have what? The normal force. You'll have what? You'll have the weight. Remember, the weight, guys, has to point downwards. Doesn't matter that thing is just on the surface like that. Always act downwards, guys. Nah? Always act downwards. When the block is like this, it always point downwards. From that center downwards, guys. Nah? Don't say something like this. Say this is the weight. If you write it like that, you have to break it into its component. I'll show you that in just a few seconds there. So now you have what? The weight. So this is the weight, and again, since it is moving between point A B, we know there is friction, so it means we have friction there. We have what? Friction, and another thing, we have what? We have the tension. So if you have to check, this format tells you how many forces you need in your what? In your free body diagram. So let's just draw that. If where can I draw this? Okay, let me just remove this here. So now I'm drawing the the thingy, né? So up like that, you have what? You have tension. And then like that, you have what? You have Fn. And then let me just break this into its component. When I break this into its component, then look what's happening. It has to be perpendicular to the what? To the surface. Yeah? It has to make a 90-degree there. So if I break it into its component, you'll have Fg perpendicular. It is what? Perpendicular, like that. And Fg parallel. This one is parallel to what? To the surface. So Fg parallel. So if I break this into its component, it means now, let me just write like that. So I'll have what? I'll have Fg parallel. I'll always advise you to write it like this, guys. This will help you for calculations. Né? Then you'll have friction. This has to like be parallel to the thingy. Né? So this is to match like that. So this is what Fg parallel. Hey, this is Fg perpendicular. What have I done? So this is what you'll have there, guys. Or write it like this. And say this is the weight, the Fn, the tension. But in this case, we need it for calculations. Né? So now 1.3, let's be fast, guys. 1.3, this is we have to calculate the magnitude of the acceleration of the block P while block P is moving on a section AB. So they're telling you focus on that AB since there is friction there. So now we know we are talking about what? Newton's second law. Newton's second law, we have to introduce that F net. It's equals to what? MA. Yeah? There is a marker, guys, for this formula. So always write down the formulas. They're given there, guys. I don't have to go back and show you the formulas about, you know, these formulas. So now, what we are just going to do, guys, since we are looking for the magnitude of the acceleration, which is like 8 marks, guys, that's a lot. So it means now we can't use just block P or block 2 kg alone. We have to also do simultaneous with what? Block Q. So I'm just going to start and say for P block. Yeah? For what? P block. So for P block, we're just going to say, okay, this is F net. So remember, we have that formula written down. So I'm just going to say the sum of what? Of Fx. What is this? The sum of Fx, meaning that we are calculating what? The sum of the forces on a horizontal component. Yeah? This part. The sum of forces on a horizontal component. This is going to help us calculate what? The acceleration. So focusing on that part there, we're just going to say, remember this is 2 equals to what? To MA. The sum of Fx has to be what? Has to be, let me just write this here, guys. Let me just write this diagram here so that we can be fast with our things. So Fg parallel like that. So we have this sum of our horizontal component. So look what we have. So remember, the block is what? Is sliding upwards. Né? It's what? It's moving like that up an incline, heading to that direction there. It means now this is gonna be positive. Those ones that are opposing the motion, they are gonna be what? Negative. So it means now it's gonna be what? Positive T, and then plus minus what? Fg parallel plus minus what? Minus F or Fk. Né? So now this is equals to what? This is equals to MA like that. The tension, are we given the tension? I don't think so. They didn't tell us about the tension, so leave it like that. So you have T plus into what? Into minus. You know that Fg, guys, Fg parallel, this is the same as what? This is the same as mg sine of theta. So Fg parallel, you're just going to substitute that. Yeah? So I'm just going to write it here. So before I make the substitution, let me just write it here. So this is minus mg sine theta minus Fk, which is equals to ma. So we know we don't have the tension minus what was the mass of the P block. This is 2 kg. So we have 2. What is the gravitational acceleration? This is 9.8. and then sine of what? Of the angle. What was the angle? The angle is given, which is what? The 30 there. So that's 30 degree. So you're just gonna say sine of what? Of 30 degree minus the friction you are given, guys. So let me show you. The friction is given here, that the frictional force is what? Is 2.5. So you go there and say what? This is 2.5, which is equals to what? The mass is what? Is 2. We are looking for acceleration. So this is T minus. So guys, I won't be using my calculator here. My thingy. I mean, I won't be showing you the calculator because that thing expired. So I have to use my own calculator now. So the physical one. So now I'm gonna multiply this. When I multiply these two, these ones here, I got like a negative 9.8 minus 2.5. So when I subtract those two, let me see. Negative 9.8 minus 2.5. This is giving me negative 12.3, which is equals to what? 2a. So I'm just gonna call this or term this my equation 1. Yeah. So now for equation 2, we're just gonna say for block Q, or for Q block. Now for Q block, okay, for Q block. So let's go there for Q block. This is the Q block. So guys, to get this right, you have to draw a free body diagram, né? For this thing, just for horizontal, even if it is vertical and horizontal, né? So if you have to check, we can break. Remember, let me just write it here first. You have Fn, you have what? You have Fg, perpendicular. You have what? Fg, what is this? Fg parallel. You also have what? A tension. And then you see you have what? You have this force here like that. So we can break this into its what? Component. The horizontal component and what? And the vertical component. So if you have to check the vertical component there, just dot the lines like that and then like that. So you're just gonna say, okay, to break this into its horizontal component, here is gonna be what? Since this is a horizontal plane, you know that this is what the x-axis. So it's gonna be what? Fx, and then the y-axis is gonna be what? It's gonna be Fy. So to draw the sum of the vertical component is gonna be what? Fn, and then what? And then Fy, and then what? Fg, perpendicular. And then this side you'll have what? You'll have the tension, and then again you'll also have what? You'll also let me just write this nice. You'll also have G parallel, and then what? Fx. Understand? Since we broke it into what? Into its component. When we combine these two, we're just gonna get what? The total force there. So it means now, guys, our horizontal component is gonna be these ones, né? Because now we are dealing with the horizontal component. Yeah? Since the acceleration is what? It's just on a horizontal plane. It's just like horizontally, not vertical. Understand? So let's go there. So now for that thing block, for P block, for Q block, I mean, so just gonna say the sum of what? Of the Fx is equals to what? Ma. So you saw there we have something like Fx, Fg parallel, and then the tension. So it means now we are going to have what? There is no friction, remember here. So it means, remember this thing is going to this direction. We can term it northeast. It is going northeast or just east, upwards like that. It means now this is positive, and then these ones that are opposing the motion are going to be what? Negative. So just going to say Fax, the force applied in the horizontal plane, plus minus what? The tension, plus minus what? Fg parallel. This is equals to what? Ma. So now Fax, this is the same as force applied. X is the same as what? Is cos of theta. Nah? The same as what? Is cos of theta. Let me show you how we manage to get that. This is the angle. You are given the angle. The angle that is adjacent to your what? Or the side that is adjacent to your angle is called what? The cos. If you use what is this? The saw curve adjacent to your angle. Now, this is what just cos. So just cos theta. So you say that this is adjacent, and then the hypotenuse, which is what the total length, which is what the force applied. So that's why we say cos there. Understand? So it is cos of theta. So it means now we're just gonna say f cos fa cos of what of theta minus t minus what? We know this is what mg sine of what of theta which is equals to what ma. So fa we are given which was like 40 cos of what of 25, guys. If you have to go back there, you see that it is what it is 25, and then the force is what is just 40 newton there. So we're dealing with what with the 3 kg. Now with what the 3 kg. So minus t minus the mass is what is 3, and then gravitational acceleration, this is 9.8 sine of what? The angle, not that angle, guys, not this angle. Yes, be careful, not this angle 25, this angle here. You see that what 30-degree angle. So it means sine of what of 30 degree, which is equal to what 3/8. So now let me use my calculator. This is 40 multiplied by cos of what of 25. This is going to give me like 36.25 to 3. Let me just leave it like that. Oh, okay. I'm just gonna say this is what I have now, and then I'm just gonna say minus what I have there. Minus what 3 multiplied by what is this? 3 multiplied by 9.8 sine of what of 30 degree. So the answer that I have overall there is gonna give me like it gave me 21.55 and then 23. I'm just gonna leave it here for the sake of rounding or errors there. So which is equals to what 3a, and then this is what our equation 2. So now let's check. This is what our equation 1, our equation 2. So now we are looking for what? We are looking for acceleration, guys. So to get rid of these tensions, what are we going to do? We're just going to say we sum them. What is the meaning of summation? Summation is that what addition. Just gonna what add them. Understand? So just gonna say equation 2 plus equation what 1. So equation, let me use black. Equation 2 plus equation 1. So equation 2 is what is this part here. So it means, look, when we are summing, we sum, we call this the left hand side, and then what the right hand side. This is the right hand side, our what our acceleration. The left hand side is what the one that has tension and what and the numerical values there. So it means when we deal with the left hand side, we deal with the left hand side, guys. So when you check, this is your left hand side, and also here this is your left hand side. So what happened when you sum equation number 2 and number 1? The tension and the tension are going to rationalize. Since you have negative t plus what the t, they're going to rationalize, and then this number plus this number that we have here minus 12.3 there. So let me subtract and see what we have. So minus that number minus 12.3, I have what now? I have 9.25 to 3. I'm just gonna round it to here, and then 3 plus 2, and then that's like 5a. Then divide both sides by 5. So the 5 and the 5 rationalizes, so therefore the acceleration is simply what? Divide this number by 5. The acceleration is simply 1.85 meters per second squared. Remember, acceleration, guys, this is what change in velocity over change in time. Velocity is measured in what? In meters per second. Time is measured in what? In second. So now when you deal with this, you'll have what? 11 meters per second into that. You take this to the numerator, you'll have what? Times n into that. You when you have the same base, you add the exponent. This is what the power of the product rule. So it's m times what? S into negative 2. So that's the unit. So this is what the acceleration, and you are done there. You see, we are done. So the acceleration is simply 1.85 meters per second, like that. Yeah? So now 2.4, if block A has now passed the point B, let's check. Has now passed point B. We know from A to B there is friction there. Yeah? So if it passes point B, now it is going to exist at what, at this 2 point B and C, which are what, frictionless. So now let's see how will its acceleration compare to that calculated in 2.3. Choose greater than, less than. This is very simple, guys. uh, Picture this, it's yourself, you're walking here, no? You are, oh, let me say you are, what is this, you are, you are driving your car here. If you are driving your car here, it will be difficult, né, to move between these 2 points A and B. The speed will be much less, like much less, né, when you're moving between these 2 points A and B. The speed, let's say, will be like 2 meters per second. But when you reach B and C, you feel like, "Ah, now this is, I'm traveling in a small surface." You see, even the speed is what is now increasing. It's not what increasing, because it is what, this point B and C, that what, they are smooth surface. So they're telling us what happened to the acceleration. Acceleration, remember, it is changing velocity over changing time. Yeah? So the velocity will increase there as you what, you go, as you're moving between this 2 point B and C. That's the rate of time there. So it means the acceleration will do what? Will be greater than the one that we calculated there. So our answer is going to be what? Greater than. It won't be less than, since now we are in what? A smooth surface. And give the reason for your answer. The reason is because of what? There is no friction. Or I can say between, or I can say, let me see, just there is no friction between between point B to what is B to C, and between point B to C. There's what? There is no friction between point B to C, or you can say it is moving in an isolated system. An isolated system, or there is or it is now in an isolated system, meaning there is no friction there. Anyway, so now let's take a look at the next questions, guys. This was like 16 marks, and again take 16 all over 150 times 100 there. So now this is called what? Projectile. So this is projectile motion. This is projectile motion. Already we are we're between 1 hour in this session, guys. We're like in 1 hour session. Like, okay, fine. So now they are saying that the stone A is thrown vertically upwards with a speed of what? Of 10 meters per second from the edge of a roof of what? Of 40 meters, you can see here. So ignore the effects of air friction. Take ground as what? As a reference. Excuse? Take ground as a reference. So now define the term free fall. I'm not gonna write this down, guys, but you know free fall, this is a motion during which the only force acting is the force of what? Of gravity. Guys, remember that. The motion during which the only force acting is the force of what? Of gravity, guys. That's what free fall. Motion during which the only force acting is what? Is the force of what? Of gravity. So I'm not going to write that down. So already we have what? Those 2 marks there. So I'm leaving that for you. So you have to like write when I'm talking there. So now, if you have to check, they are saying that we have to calculate the maximum height above the ground reached by point A. So if you have to check already, this ball here is what? Is 40 meters above what? The ground. So to calculate the height, or the maximum height above the ground reached by point A, we need to find what? We need to find the height between A up to what? To the maximum there, which is what? The maximum, where we know that the velocity there is simply what? Is 0 meters per second there. Understand? So we're just going to use the equations of motions. So already I know them by heart. So we are not going to go back there and show you how to get those those formulas there. You know them. Go to the equations of motions there, you'll find them. So you know that equation number one, you have what? You have the V final, which is equal to what? The V initial plus A change in what? In T. That's the equation number one. And then equation number two is what? Is Vf squared, which is equal to what? V initial squared plus 2A change in what? In Y. Equation number three is what? Equation number three, this is what? This is change in Y, which is equal to what? V initial change in T plus half A change in what? In T squared. Those are what? Equations of motions. Of course, we don't need equation number three, guys. Once you have these three equations, you are able to what? To calculate anything that you need, to determine anything that you need there. So we're just going to find the distance from A up to what? The maximum there, where the speed is what? Is 0. Yeah? You're just going to calculate what? That height there. So if you have to check, we have V initial. And of course, guys, you have to like choose the equation or take the direction of motion to be what? Positive. So let's take up to be what? To be positive there. So let's see what we're answering. This is 3.2. So 3.2 there, we're just going to say, okay, let's see. Are we going to use equation number one? Nope. Why? Because we know what we are looking for. We are not looking for time. We are looking for what? For the distance. So equation number one, we are not going to use it there. What about equation number two? Equation number two, we don't have time. We can use equation number two there. So it means now this is going to be what? This is going to be V f squared, which is equal to what? V initial squared plus 2A change in what? In Y. We took up to be positive. That's the direction of what? Of motion. Always take the direction of motion to be what? Positive. Don't change the direction, guys. Once you choose up or down to be positive, keep it like that. Understand? So now the V final, we know the V final there at the maximum height is going to be what? 0 meters squared there. So 0, not meters squared, but 0 meters. So in this case, substitute, you will have 0 squared, which is equal to what? The V initial is going to be positive 10 meters per second, since we chose up to be positive, plus 2A. What is acceleration? Acceleration, this is 9.8 meters per second downwards. It's always what? Downwards. So it means now, since it's always downwards and we took up to be positive, this is going to be what? Negative 9.8. We are looking for what? We are looking for the distance there. So this is change in Y like that. So it means now we know this is going to be 0, guys. No, this is going to be 0. So I'm just going to take this, since it is negative as C, it is negative here. 2 times negative 9.8, that's going to give you 19.6. Take that to what? To your left. You're just going to have a positive 19.6 changing Y, which is equal to what? 10 squared there. What is 10 squared? 10 squared is 100, guys. This is 100 divided by 19.6, both sides 19.6. So this rationalizes, so therefore change in Y is simply what? 100 divided by 19.6. That's like 5.10. So 5.10 meters like that. So let me confirm. 2 times 9.8, that's like 19.6. So now, guys, this is what? The distance from what? From point A, from the edge of a building to what? To the maximum height. So we know this height there. But the question is what? The question is this. Calculate the maximum height above the ground reached by stone A above the ground. So it means we're just going to sum this one plus that one there to get what? The maximum height reached by point A. So I'm just going to say that therefore the maximum height above the ground is going to be what? Is going to be change in Y, that one, change in Y. So let me just say is equals to change in Y plus what? The 40, change in Y makes this one, plus what? Plus 40. So your answer there is going to be what? Is going to be, let me say max height is going to be what? It's going to be 5.10 plus 40 And of course, this is in meters. So therefore, let me see, that's gonna be 40 something, 45 now. So 40 plus 5.10, that's like 45.1. So now therefore this is 45.1 meters above what? Above the ground. So now that's the answer there. So now if you have to check, they say that you have 3.3. Now in 3.3, they're asking what? They are saying that you have to write down the magnitude and the direction of the acceleration of stone A at this maximum height. You know that the magnitude and the direction of this stone A. What happened to the acceleration? You know the acceleration, guys. We are talking about what here? We are talking about the gravitational acceleration, which is what? 9.8. Let me write that down. 9.8 meters per second. Downwards. Ne? Downwards. 9.8 meters per second downwards. That's what the acceleration of stone A at the maximum height there. It will be what? 9.8. This value doesn't change, guys. So it means now the direction, right, and the magnitude, the magnitude of this stone here, it is going to be what? It's going to be G, which is what? 9.8. Since they said magnitude, so let me just say 9.8 meters per second squared, like that, meters per second, what? Downwards. Since they said also the direction, so downwards. It's always acting what? Downwards, guys. Write down the magnitude and the direction of the acceleration of a stone A and this. You don't have to worry about the sign, guys. You just have to say what? Negative 9.8 downwards. Once you state it downwards, it means now, since we took up to be positive, we don't care. We no longer care about what the sign, guys. So now they say that stone B is dropped from the rest of the edge of what? From rest of the edge of what? The roof. That same roof there. So let me picture this for us. So remember, this is 40 mil. You have A, which was projected upwards. It was projected upwards at what? Let me check. At 10 meters. So at 10 meters per second. And then again, they are telling us that we have what? We have let me just use green. So now this is stone B is dropped from rest from the edge of what? Of the roof, X seconds after stone A was thrown. X seconds after stone A was what? Was thrown. So it means now we have another ball there, which I can just term it what? B. It was dropped. What is the meaning of drop? It means now the V initial there is going to be what? The 0 meters per second. So now, what do we need? We're just going to say, all right, they're saying that 3.4, stone A passes stone B when the two stones are 29 point what? 0.7 meter above the ground. Calculate the value of X. Guys, don't be tempted. Don't use this value there. Don't be tempted. They're saying that this is what? The 29.7 meter above what? The ground. So it means like from here to there, that's what? That's the distance, 29.74. But we know that these balls are coming from what? From the edge of a building. This height, this is what we need, not about this one. So what we are going to say is that before, we know we have to calculate that value of X, which is what this the time of stone B, X second after it was stone A was what? Was thrown. So just going to say, okay, change in Y is going to be what? Is going to be 40 and then subtract 29.74. And of course, this is what? In meters. So therefore, change in Y here is going to be what? Is going to be, let me see. So this is 40, subtract 29.74. This is 10.26, and then meters. So now we are going to use what? This height, guys. We are going to what? To use this height. Don't be tempted to use this one. So now we still remember the equations of motions. Now, so what you are going to do is this. We are looking for what? For the time. It means we are not going to use equation number 2, because equation number 2, what we know is that we have the height and not the time there. So it means we have to use equation number 1 and equation number 3. Yeah. So we know that. Let me just write it down here. So equation number 1, guys, we know this is Vf, which is equals to V initial plus A change in T. Equation number 2, if you need equation number 2, equation number 2, this is what? This is our Vf squared, which is equals to V initial squared plus 2 A change in Y. And then equation number 3, this is the one that we are not going to use this one. Oh, we have to use it since we are looking for time. So it means now this is change in Y, which is equals to what? V initial change in T plus a half A change in T squared. Sorry for space there. So I had to squeeze it there. So now, guys, come back. Let's come back here. So we need to find the equation, or use the equation that we know that we are going to find or determine the change in time there. So if we are to check, equation number 1, we have time. Equation number 2, we still have time. Yeah. So now let's make use of what? Of equation number 3 there. Why equation number 3, guys? Equation number 3, we know that these two balls, stone A and stone B, they travel some distance. Now, some certain what? Distance. So you're not just gonna use equation number 1 there, because what are you doing with equation number 1 since you don't know the change in Y there? You see, it's gonna be a trouble. Yeah? So apply equation number 3 there. So equation number 3, which is this one, we are going to say what? Let me mix these colors now to help you for your brain. So it means now you're just gonna say change in Y is equals to what? Is equals to V initial change in T plus a half of what? Of A change in T squared. So now let's start with stone A. Now let's start with what? With stone A. Let's start with stone A. So starting with stone A, change in Y, we know we took up to be positive. We took up to be positive, but now this time the ball is going downwards, because now the thing as the stone A passes stone B. So it means now, since it is going downwards, guys, since it is going downwards, what happened to everything, guys? Everything, remember, we took up to be positive, but now the stone is going where? Is going downwards. So everything that it is going to pass there is going to be what? Negative. The height is going to be what? Negative there. So it means now we're just going to say this is negative what? 10.26. Since the stone is going where? Downwards, but we took up to be positive. So now, because now the motion is downwards, guys. So this change in Y is what? Is negative 10.26 there. V initial, the velocity initial, we know it is 10. So we know it is positive what? 10 there. We are looking for what? For the time. Plus a half A, but we know acceleration, this is going to be negative 9 point that, and the change in time squared. So now, this part here, let's see which one we are going to take to that left. Okay, I see a quadratic formula here. I see a quadratic equation here. Because now you'll have negative 10.26, which is equals to 10 change in T. The half of negative 9 point, the half of 9.8, this is negative 4.9. Let me compare. So 9.8 divided by 2, this is 4.9. So change in T squared. We're just gonna take this to the what? To the right there, and it is going to become what? Positive. So this is going to be what? Negative 4.9 change in T squared plus 10 change in T plus what? Plus 10.26. Yeah, plus what? 10.26. I hope you can see that, guys. So now we are going to apply the equation of the quadratic equation. Remember, the quadratic equation is like this: x is equals to negative b plus minus the square root of what? Of b squared minus 4ac all over 2a. This is our A, our B, our C. Hey, let me just remove that. Someone will say, oh, I'm dividing. I'm not dividing. I'm just showing you those variables there, the coefficient in front of what? Of the variable that we have, which is what? Change in t. We are not solving for x, we're solving for what? For change in t. So it means we have to say what? Change in t equals 2. You have that negative there. The b is going to be what? 10. So this is 10 plus minus the root of what? Of the b squared, which is what? The 10 squared, the minus 4a is what? Is negative 4.9. C is what? Is 10.26. And then all over what? All over 2. What is the a? Oh, the a is negative 4.9. Negative 4.9. So therefore, change in t here. Let's see what we have. So now, this is negative 10 plus the square root of what? Of 10 squared minus 4 minus 4.9, 10.26 2 into negative 4.9. And then the answer that I have here is negative 0.75, or change in t is equals to, let me check. When I put a negative sign there, I have what? I have 2.79 seconds. This is seconds. So, you know, guys, time is positive. It's always what? Positive. You can never have a positive time there. So it means now, therefore, change in t for a there, change in t for a is gonna be what? It's gonna be 2.79. So this is the time it took for ball A to travel that distance 10.26 there, when it is what? 29.7 above what? The ground. So this is the time of what? Of A. But you're not done, guys. We're not looking for that time, guys. We have to calculate the time for B. Remember. So now we're just gonna say stone B now. Stone B now. This is not cold ring. It's not stone that you know. It's a stone rock. Just kidding. So now stone B, the same equation applies. So change. Remember, there is a mark for a correct equation. So let me use another color so that to help you with your brain there. So this is change in Y, which is equals to what? B, initial change in T, plus a half A change in T squared. So now, guys, I want to teach you something now. So now, let's go back to the statement. They're saying that stone B is dropped from rest from the edge of a roof X seconds after stone A was what? Was thrown. So now my question is, when stone A is traveling for, let's say when stone A is traveling for 3 seconds, stone B will be traveling for how long? It will be traveling for how long? It will be traveling for what? For 3 seconds minus what? Minus X. That's the answer. That's the time of what? Of stone A out of stone B. That will be the time stone B will be traveling. When stone A is traveling for how long? For 3 seconds. Understand? Because it is dropped after, or it is dropped from rest X seconds after stone A was what? Was thrown. Stone A was already in what? In the air. And then now we are dropping what? Stone B. X seconds after. It means now stone B is traveling for how long? It's traveling for 3 seconds minus what? Minus X. So now we're going to use this equation there, but not 3 seconds. That was just for emphasizing. So it means now we're just going to say, we know this is what? This is negative 10.26. Remember, this negative 10.6 comes from here. Comes from here. This one that we have there. So why negative 10.6? Because stone A is going downwards. The V initial for stone A is 0. So this part is going to forfeit. You left 0 plus what? Plus a half into what? Into the acceleration is negative 9.8. Guys, keep that equation, that direction to be positive. Like, keep it like that. Don't change for, like, let's say, because now we're dealing with stone B, you have to change the direction. Now maintain the direction. So we're looking for what? For the time there. So to look for the time, it means now when stone A is thrown, stone B is traveling for how long? It's traveling for change in T minus X. Understand? And then square it like that. So this is what? This is negative 10.26 which is equals to what? We know change in t, which is what? 2.79. This is the time of what? Of stone A. So it means now the half of what? Of negative 9.8, or the half of 9.8 is gonna give us what? 4.9. But in this case, we have what? A negative sign there. So we'll have a negative 4.9, which is what? 2 point, what is this? You left 2.79 minus x squared like that. So I'm just gonna divide with by negative 4.9. It's gonna cancel those signs there, those negative signs. So it's gonna make this to be positive. So let me see what's my the answer that I have there. 10.26 divided by 4.9. So now I'm just gonna keep it like this, guys, because I don't want to make rounding errors. Now for now, let's just keep this as a fraction like this. So we have 4.9, which is equals to what? You have what? This 2 now tells you you have a squared binomial. So to deal with the square binomial, you simply say what? This first number, 2.79 times 2.79. It's going to give you what? Let me see. 2.79 times 2.79 is going to give us what? 7.7841. The same number times what? X is going to give us what? The negative, because of this sign, negative 2.9x. Multiply that by 2 is going to give us what? You left this, guys. You left negative 2.79x. And again, when you multiply this with this again, you'll have negative what? 2.79x. So now the summation of this is going to give us what? 2.79 minus, or 2.79 plus 2.79. This is what? This is what is this? This is 5, né? Minus 5 minus 5.58x. And then x times x, the sign is going to change. Negative x times negative x is going to give us what? A positive x squared there. So it means now we have what? A positive x squared. So if you have to check, it seems like again we have this thing, a quadratic formula. But don't worry, we'll take this to the left there. So it means this is 0 is equals to 7, this number, subtract that fraction, 7.7841 minus 10.26 divided by 4.9. So the answer is going to be what? The answer is going to be 5.69. I'm just going to keep it here, guys. So, and then minus 5.58x plus x squared, like that. Then plus what? X squared, like that. So now, again, we are going to use what? A quadratic formula, which is what? X is equals to negative b plus minus the square root of what? Of b squared minus 4ac, all over what? 2a there. So now, you have what? We are solving for x. So this is our a, b, and then what? The c there. So the order has to what? To make sense, guys, when you look at it. So this is negative, and then b is what? Is this answer with its sign, the coefficient in front of what? Of x. The coefficient, this is the number in front of what? That variable. In this case, is what? Is x. Excuse. So this is 5.8 plus minus the root of what? Of your b, which is negative 5.58, and then square the minus 4. The a is what? Is 5.69, and then the c is what? Hey, this is a, ne? So you see I'm making mistakes. They always arrange, guys. So it is 4a. A is what? Is 1. And then c is what? Is 5.69. Like that. You see? I was so close to making mistakes. So this is 2a is what? Is 1. So therefore x is simply what? Let me take out my calculator and see what we have there. So now this is negative into negative 5.58 plus the square root of what? Negative 5.58, and then square the minus 1 into 5.69, and then 2 times 1. So the answer that I have here is 4.2371, or x is equals to, let's see, I'm sure this is going to give us negative here. So okay, this is positive again. So this is what 1.34 and then 2899. Let me just write it. So which one is x? Which one is x? We know that we are subtracting from what? From this value there. And we did, we subtract from that value. Then if we subtract from that value, we shouldn't get like the value that is greater than the change in time that we have here, because it has to be a smaller number. Yeah? So if let's say if A is traveling for like 2 seconds, yeah? If A is traveling for 2 seconds, then B will be traveling for how long? It will be traveling like less compared to what? To A there. So TB will find that it's traveling for how long? For like 1 second. So it means now we are not going to use the 4.2 something. So X cannot be that answer. So therefore, X should be what? Less than that answer, because we subtracted here, changing T minus X. So the answer has to be what? 1.34 seconds. This is our answer, guys. This is our answer. You see, it was very simple there. So let me just go back there. I hope you can see. Let's take a look at the next question. Okay, so now still projectile. Eh? Let me just jot it down here. So this is projectile. Projectile motion. So now they're saying what now? They're saying that the graphs of the position versus the time, or the graphs of position versus time for part of the motion of both stones are shown below. And this makes sense, guys. We are so sure that this graph here, this has to be graph of what? Of B, because it was thrown or dropped X seconds after what? After stone A. So this has to be the graph of what? Of stone A, because it started from the edge of a building, starting from zero. The time was zero. But for this stone B, it was thrown some seconds, yeah, after what? After A. So it has to have a delay. This is a delay. DEF is what? Is a delay, or DE is a delay, and then it was dropped at this what? F there. So now they're saying that which of the labels A to H, A to H on the graphs above represent the H of the following. Let's make sure that we get this right. The time at which stone A has a positive velocity. This is very simple. The time at which stone A has a positive what? Velocity. And again, this shows what? A motion that they chose like up to be positive, guys. They chose what? Up to be what? To be positive. They chose up to be positive. Why am I saying up to be positive? Because you can see the graph here. It shows exactly how the ball went from B up to C there, like that. So now they're saying the time at which stone A has a positive velocity. The time at which, guys, listen, don't rush into the question. I know some of you already thinking of what of B. The answer is no. The time. They're looking for the time. So it means now we have to read here. We have to have time. These E and F, they're showing us what? The period. Understand? The what? The period. So if you have to check, this happens at what? At the DE. So this is not exactly D, because they're saying which labels each of graphs above represent each of the following. The time at which stone A, okay, the time. If it is this time, it has to be what? It has to be D. So answer is D, because they're talking about what? The time. So we know that at this part here, stone A will have what? A positive velocity there. Then at time what? At time D. So they're saying which of the labels um, on the graph above represent each of the following: the time at which the time at which, oh, I don't know if I'm getting this right. Let's see. Which of the labels A to H on the graphs above represent each of the following: the time at which stone A has a positive velocity. The time at which stone A has a positive velocity. It has to be D, guys. Yeah? It has to be what? It has to be D. Because if you can see here, this shows what when what is this? Let's say when A is sometimes it's like D, it's like a D there. Now it is what? It has a positive velocity. I think the answer is to be like H against there. The answer is to be H. We'll come back. Yeah? We'll come back. So now they're saying which of the labels A to H shows the maximum height reached by stone A. This is very simple. You just look at the curve there. Whenever it curves like that, that's the maximum height. So they're saying which of the labels A to H on the graph above represent each of the following: the maximum height reached by stone A. So the maximum height reached by stone A has to be what? Has to be A there. Then this is the A, the maximum height. They're talking about the maximum height. The position is what? Is always about what? The height. So it means now the answer is going to be what? A. And the answer here is going to be D, since they're talking about what? The time. So we have to look at the time, the letters that represent what? The time, guys. When they're talking about the height, you have to look. The position is always about what? The height there. You look at these letters here. You understand? You look at those what? Letters there. So now the time when stone B was dropped. This is the time. They're looking for about what? So listen the question carefully. The time. So it means F is going to be what? The answer there. Because this shows the time stone A was what? Was dropped. Understand? So you see now we're getting this right. So now they say the height at which the stones pass each other. So it means now they're talking about what? The position here. So it means your C has to be what? The answer. So C is the answer there. You understand? Those are your answer. So again, 18 all over 150 times 100. You know our rule. See what you got there. Let's move to the next question. Woo! This is what now? I think this is like work, energy, and power. Nope. It is what? It is momentum. Yes, it is momentum, guys. This is momentum in energy, guys. It is called the momentum in energy. Question 4, momentum in what? In energy. So now, let's look at this very fast. Very quick, very quick. So I think I have black there. So let me change that. Let's see, I can place this. And of course, leave that. Okay, so now, enough of the talking. A bullet moves east at a velocity of what? Of 480 degrees. It hits the wooden block that is fixed to the floor. The bullet strikes, the bullet takes 0. Okay, so we're given the time change in t. This gives simply 0.01 seconds to move through the stationary block and emerges from the block at a velocity of what? This is the v. So this is initial, the velocity initial, and the velocity what? Final. There. So ignore effects of air resistance. Okay. So now consider the block system as an isolated. You know what about an isolated? This is the system on which the net external or the resultant forces are what? Are 0. And again, they're asking about what? The that definition here. It is what? The system on which the net external forces is what? Is 0. Né? Is the system where the net external forces is what? Is 0. Or is the system on which the resultant or the net external forces is 0. Let's keep it to that. Né? So that's what the definition. Because now, I still remember them by now, guys. You see? So I know what's an isolated system. So if you want to memorize them, memorize them. So now I don't learn to forget things, guys. So now you have to love what you're doing. So now the magnitude of the momentum of the bullet before it enters the block is what? Is this. That giving you what? This is the momentum. They're giving you what? Momentum that is equal to what? 24 kg meters per second. Let me show you how. Remember, momentum is what? Is mass times what? The velocity. Mass is measured in what? In kg. The velocity is measured in what? In meters per second. So this is exactly what you have there. So that's the momentum. They say now calculate the mass of a bullet for 3 marks. So it is, we are just going to apply momentum. So P is equals to what? M times velocity. M times velocity. We are given the momentum, which is what? 24 what kg meters per second. And then this is to equals to what? We are calculating the mass. So M times what? The velocity, that thing, the magnitude of the momentum of the bullet before. So it means we have to use what? The initial velocity, which is what? The 480 there, meters per second. So we divide both sides by 480 meters per second, divide by 480 meters per second. So the meters per second, the meters per second rationalize, this and this rationalize, and this and this rationalize. So therefore, the mass is simply what? 24 24 divided by 480. This is 0.05 kg there, the units. You see, I don't have to think about the units there. So now, next question. This is one. I think this is the last question for this question here. So now, they're saying that, let me just jot it down here, 4.2.2. Calculate the average net force exerted by the wooden block on the bullet there. So that's very simple. We're just going to apply that formula that F net is equals to what? Is equals to MA. But we know that acceleration is the same as what? Change in velocity all over what? All over change in time. So all over 1 there multiplied there, you'll have what? You'll have M change in velocity, M change in what? In velocity, all over what? All over change in time there. And you are given what? The time. So it there. So it means now therefore the F net is simply what? Is simply M change in velocity all over change in t, which is the same as what? As change in momentum all over change in t there. So now calculate the average net force. This force exerted by the wooden block on the bullet. So that's very simple. We need the momentum before or since this is changing momentum. It means changing momentum. Remember, this is momentum final minus momentum initial. Just gonna make the substitution here. Understand? So it means now you're just gonna say this is P final minus P initial all over change in T. Just gonna take this down. So it means now I have what? I know momentum I know momentum is what? Is M velocity there. So it means now this is the mass multiplied by the velocity final minus the mass multiplied by the velocity initial all over change in T. You can see that the M and the M is the same. So now that's your factor. Factor that out, you'll have what? You'll have M into what? Into V final minus V initial all over what? All over change in T. So therefore, this is what your net force. We haven't calculated yet. So now let's make the substitute. Let's do the calculation. You are given the mass, or we calculated the mass 0.05. The velocity final, I recorded it there. It is this one, 80. And we have to subtract what? The initial velocity of the bullet, which is 480 meters per second. So this is 480 all over the time it is given to us, which is 0.01 second. So 0.01 second. So now let me take out the calculator and see what you have there. So this is 0.005 into 80 minus 480 into 001 and then into that. Oh, sorry. So let me see. I have a negative. Let me just put it down here. Therefore, the F net is equals to negative 200 newtons. What is this negative telling you, guys? You don't leave your answer like this. This negative tells you about what? The direction. So conclude and say, therefore, F net is equals to, remember, east is taken as positive there. To the east taken as positive. So if it is negative, it's going to the what? To the west. So it means now this is what? 2000 Newton to what? West. So this is what our answer then. We are done, guys. Yeah? We are what? We are done, guys. So now, next question. Whew. Let's see how long we have been recording. Okay, for 2 hours. Huh. And we are in question 5, just question 5. Okay, so now question 5, this is what? This is work, energy, and the power, guys. This is work, energy, and power. So now, what happened there? You find that I'm no longer recording. Okay, guys, so now, let me remove that things there. Okay, an object of a mass 1.8 kg slides down a rough curve. You see, there is what? Once you hear about rough, it's all about what? The friction. There is what? Friction, guys. Remember that. So it means there is friction. This system is not what? Isolated system. Because there is what? There is the net external forces. Excuse, it's not gonna be zero there. So now let's see, because since there is friction, that friction is going to affect the motion of this object. So initially and finally it's not going to be the same, guys. So now, because you can see the speed between these 2 points, they're not the same. So now they're saying that the object reaches point B at the bottom, it triggers the, okay, that doesn't matter. So now conservative forces, guys, should I write that down? Nope. Conservative forces, this is a forces for which work is done in moving an object between 2 points is independent to the path taken. You see, let's say that you have a map like this, and this is point, okay, let me just say this is point A, this is point B. Let's say there is we have to go like that, yeah? And then again there is this one that we have to go like that. This is the path, né? This is path 1, and then this is path 2. So now conservative forces is like this. It's a gravitational force. Gravitational force doesn't depend which path you take. Yeah? You can either choose to take the longer path, gravity won't be affected. You take the shorter path, gravity won't be affected. So those are what are conservative forces. The non-conservative forces, there we're talking about the friction. Yeah? So now, the conservative forces, this is the force for which work is done in moving an object between 2 points, is independent, doesn't depend on the path taken. So it's independent to the path taken. Understand? So now, they say name the conservative force acting on the object. We know it's always what? Gravitational force. Always, guys. It's always what? Gravitational force. So now, is mechanical energy conserved as object slides from A to B to point B? I told you the answer is no. So the answer here is no. They are saying what? Why are we saying no? Because there is what? There is friction there. Is it? There is what? There is friction, or this is not, or the system is not isolated. You can say like that. The system is not isolated. So since it is not isolated, this means now something is going to affect this block as it moves from point A to B. You can see the speed is not the same. So since the speed changes, you can see that now this is affected. So the system is what? Not isolated. Or there is a presence of what? Of friction. You can say like that. So now 5.4, calculate the gravitational potential energy of the object when it was at point A. We know that gravitational potential energy, this is EP, which is the same as what? As the mass multiplied by the gravitational acceleration multiplied by what? By the height. This is the motion due to what? Due to height. That's what gravitational potential energy. This is a motion of an object due to what? Its height or its position. Understand? So now the mass of what? Of this block, it's only one block, which is what? 1.8 kg. So 1.8. The gravitational acceleration, this is 9.8. The height, we are given the height. Let's say when it is 8.A, I mean, this is the height, we are given 1.5. So this is 1.5 there. So let's see the answer. We know since we're calculating the energy, this has to be in joules. Those are what? Well, that's the units there. We have to use. So now 1.5. So I'm getting 26.46 joules of energy. Right? So calculate the gravitational potential energy of the block when it was 8.8. So that's the energy there. So now, using energy principles, calculate the work done by friction on the object as it slides from point A to point B. Let me show you the equations of let me show you the energy principles. Né? Excuse guys. So now, when they say use energy principles, you come here, guys. Né? This is where your answers are. They're talking about us, or they're telling us that we should find what? The work done by friction. So we know that this formula is the work done by non-conservative forces, which is what? The friction, the force applied, and so on. Yeah? Which is the force for which work is done in moving an object between 2 points is dependent. In this case, it depends on the path taken. So the work done by non-conservative forces will be what? The work done by what? By friction. You understand? So I'm just gonna use what? This formula, or apply like this. Yeah? It is change in EK plus change in what? In EP. So now let's use that formula. Né? We are answering what? 5.5. So this is 5. Let me just take it here. So this is 5.5. So now you saw that formula. It is what? The work done by non-conservative forces. WNC is equals to what? Change in the kinetic energy plus change in the EP. Yeah? So now we need to calculate the work done by what? By friction. It means we're just gonna say what? WF there. The work done by what? By friction. So WF is gonna be what? Change in kinetic energy. Remember, EK is simply half mv squared. So it means we're just gonna say what? So since it is change, it has to be final minus initial. So it's just gonna be half mv squared final minus half mv squared initial plus EP. You know it is the same as what? As mgh. So this involves what? About the position, how an object is positioned. So it is same is what? Is mghe, final, not initial. Since you have changed, is final. It's always final minus initial. So minus ghe initial. So now you can see that we have the half m. So those are what? Your factors. Factor those out. So you'll have half m, and you'll be left with what? With f squared minus v initial squared, and then plus, in this case again, the mg and the mg will be your factors. So mg, and then you have hef minus he initial. So now I'm just gonna make the substitutions. So now I'm gonna say this is half into the mass is what was that? Is the mass 1.8, guys? Let me check. Yeah, the mass is 1.8. I thought it's 1.3. So it is 1.8. The velocity final, it is given to us. This is 4 meters. Initially, it is what? 0.95. So 4 minus 0.95. And this is what? Hey, what have I done there? So this is 4 squared minus 0.95 squared plus the mass is the same, 9.8 into that gravitational acceleration. The height initially, I think it was like 1.5. So this is he initial, he final will be here, and it will be 0 here because of why? Because we know this is mghe. These are constant, they don't change, but the height here, we don't have height at point B, so the height is going to be what? 0 there. Understand? So it means now you're just gonna say what? HE final is gonna be 0 minus HE initial. This is 1.5. Understand? It was 1.5. Let me double check or cross check that. This is 1.5. So it's like that. So it means now, let me take out the calculator. So this is what? Half 1.8 4 squared minus 0.95 squared plus 1.8 9.8 then into minus 1.5. This is 1.5, guys. So I got an answer of negative 12.87. So it means now, therefore, the work done by friction is simply negative that joules. So this is what. So now the energy tells you that the negative tells you that energy is what is lost from the system. That's why this is what, this is not an isolated system. That's why they say, is mechanical energy conserved? The answer is no, because there is the work done by friction, which is removing energy from our system. So from that energy that we got there, remove that 12, you see, we are losing energy. So this system is not what? It's not conserved. Yeah. So now let's say surface BC. Let's take a look at that. So this is surface BC. They're telling us that in the diagram it is frictionless, meaning that it is smooth. It's a smooth surface. There is no friction. They're saying 5.6. What is the value of the net work done on an object as it slides from point B? We know, since it is the work done, or the net work done, which is W net. W net there is gonna be what? The work done by what? By friction plus the work done by what? By Fg plus the work done by what? By Fn. The work done by friction, since there is no friction, this is gonna be what? This is gonna go away, is 0. The work done by Fg, remember, work is simply F changing X cos of what? Of theta. So now the force is going to be this. So this is the force. You don't even know the force, but you don't have to worry. And then changing X cos of what? Of the angle. So if you have to check, your object is going to this direction. This is your block. Your object is going to this direction there. So if you have to check now, what is the work done by what? By the gravitational force. It is going to be what? Gravity always acts perpendicular to what? To the surface and the motion of an object. So it means now it forms what? A 90-degree angle. So since it is what? Perpendicular to what? To the motion of what? Of your object there. So since it is perpendicular, you know that this is going to be what? Cos of what? Of 90 degree. And cos of 90 degrees is going to give you what? 0. So now the work done by Fg is going to be 0. So this is also 0. And again, the work done by Fn is also perpendicular to the what? To the motion of an object. So it's also going to be what? 0 there. Cos of 90 is what? Is 0. So it means now the net work done there is going to be what? 0. So therefore, W net is simply what? 0 joules. Okay? That is what the answer there is. We are done. You know the rule. 18 all over 150 times 100% tell us what we got up until now. So now, this is what? This is Doppler, guys. So let me see how long we've been recording. Okay, this is Doppler effect. This is what? Doppler effect. So now, guys, they're saying that the siren of a police car, which is traveling at a constant velocity, that's very important there. So I can just highlight those keywords. So they're saying that along a straight line horizontal road, it emits sound waves of a constant frequency, meaning a constant frequency means something which is what? Not changing. Understand? It is what? Not changing as time proceeds. So now they're telling you that the detector P is placed inside the police car. That's very important then. Let me picture this for you. We have a police car like this. Now, we have what? A police car like this. It emits sound wave like that. We know it emitting what? It's emitting sound wave like that. But if we have a detector inside or placed inside the police car, it means now the frequency of the source, which is what? The police car, is gonna be what? The same as the frequency of what? Or the frequency of this listener, which is detector P, is gonna be the same as the frequency of what? Of the source. Why? Because they are, that source or that detector is placed inside what? The police car. So the frequency is gonna be what? The same there. So the frequency of the source is gonna be the same as what? The frequency of what? Of the detector, which is what? The P there. Understand? Which you can call listener P. So now they're saying that and the detector P, or we have another detector. Okay, let me highlight that. We have another detector Q, which is what? Which is placed next to the road at a certain distance away. You see, away from what? From the car. So meaning away, you're not gonna place the detector here and say it's away. If you place it here, now the car is moving towards our detector Q. So meaning away, our detector has to be where? Here. No? So this is the detector what? Q there. So it means now the wavelength is gonna be what? Longer this side. And what happens when there is longer wavelength? When there is longer wavelengths, now the frequency is what? Is less. Since you know this formula that the speed of sound in the air is what? Is the frequency multiplied by what? The wavelength. So when you divide both sides by the wavelength there, see what happens. The wavelength and the wavelength, which is lambda, they are going to what? Rationalize each other. So it means now the frequency is what? Is the velocity or the speed of sound in the air divided by what? By lambda. So if you have to check this relationship there, it means now, check something. The frequency is directly proportional to what? To the speed of sound. And again, the frequency is what? Is inversely proportional to what? To lambda, which is what? Your wavelength there. So once there is a longer wavelength, what happened to frequency? Frequency decreases, or frequency is now less. So this detector Q, the frequency is going to be what? Less than what is emitted by what? The source. So it means now, let's check. They're saying that graph A graph A, air pressure versus the time recorded by detector P in the card. So this is the graph that we have that is recorded using what? The detector P there. So again, we have graph B, which is what? The air pressure versus the time recorded by detector Q next to the road. So now let's get into the questions. They're saying that in 6.1, different patterns are shown above for the same sound wave emitted by the siren. What phenomenon is illustrated by the two detectors showing the different pattern? We know this is Doppler effect. So the phenomenon that we have here is what? Doppler effect. So that's what the answer there. So it means now this is what? Doppler effect. So that's our answer, Doppler effect. You don't have to think about anything there. That's Doppler effect. That's the phenomenon there. Once you have the siren, the police cars like that, that's what Doppler effect. So it means now this is what Doppler effect like that. So this is what the answer. So now 6.2. But let's first read the statement there. The police car is moving away from detector Q. Okay, we have been told that before in what the statement that we read above. We know that detector Q is away from what? The sound source, which is what? The police car. So now in 6.2, they're telling you that use the graphs and they give a reason why it can be confirmed that the police car is moving away from detector Q. I told you that once something is moving away from your listener, the wavelength is what? Is longer. And the time that is going to take to complete one full cycle or one wave there is going to be what? Longer than it is in the front there. Because you have what? Shorter wavelength. But at compared to Q, there is what a longer wavelength. So the time that is going to take to complete one full cycle, which is what the wavelength is going to be what longer. So if you have to check there, they are asking for the evidence to confirm that the police car is moving away from detector Q by using the graph that we have there. So now we're just going to say, since they're talking about Q, we know this is what the detector Q graph. So if you have to check this, you count it. This is how you see that this is the one full cycle. You start by numbering 1, 2, 3, 4, 5. So 1 up to 5, guys, we call that what? One full cycle. So that's the time it took to complete what? One full cycle. Check detector P. This is the time it took to complete one full cycle. So one full cycle is, you count from 1 up to 5. That's one full cycle. Now, 1 to 5. From 5 to 6, that's half to 5. From 5 to 6, that's half of what? Of a full cycle. So now, check detector P. Detector P, this is the time it took to complete one full cycle. This is 17 times 10 to the power negative 4. But check detector Q. It took how long? 18 times 10 to the power negative 4 seconds. You see, that's longer compared to detector Q, which is what? Inside the police car. So this is telling you that this is the evidence that we needed, that indeed the police car is moving away from detector Q. You understand? Because the time it took to complete one full cycle is longer. So that's the reason. So we can say now the time it took to complete one full cycle, which is what? 18 times 10 to the power minus 4 seconds, is what? Is longer. You see, the time it took to complete one full cycle is longer, or the time it took to complete the wave there, or the period it took there. So that's your answer, guys. You can answer anyhow, as long as you understand what's happening there. Understand? So now, next question. Calculate what? The frequency of the sound wave recorded by the detector. The sound wave recorded by the detector. There is this formula, guys, that frequency is equal to what? 1 all over what? The period. Let me show you from what? The table that we have there. So now, this is the formula, guys. Can you see? This is the formula that we have here. So remember, I said the frequency is equal to what? 1 all over T there. But if you have to check this one, so to make it F the subject of the formula, you have to cross multiply. You have TF is equal to what? 1. Divide by T, divide by T. So it means now, therefore, F is simply what? 1 all over T. So this is what the formula that you have there. You can either write it like this, they will give you a mark. You can either write it like this, they will give you a mark. Remember, in physics, there's always a mark for the correct formula. Understand? So let's go back there and answer our questions. So, okay, this is what the formula that we have. We have here to calculate what? The frequency of a sound wave. So now, we are going to say this is the frequency into 1 all over T. This is the period it took to complete one full cycle. That's what the wave, guys. So now, going back there, so they're talking about what? Detector Q. So since they're talking about detector Q, they're saying calculate the frequency of the sound wave recorded by detector P. They're saying detector P. Be careful, guys. You see detector P. So we shouldn't use the graph of what? Of detector Q. We have to look at the graph of what? Detector P. We know that the time it took to complete one full cycle, this is when we count from 1 up to 5. That's 17 times 10 to the power negative 4. Understand? So it means now the time is going to be what? 17 times 10 to the power negative 4. So it means now, therefore, the frequency is going to be what? Let me see. So this is 1 all over 17 times 10 to the power negative 4. So I have like 588. Let me write that nice so that you can see point what? 0.2 hertz. Remember, frequency is measured in what? It's measured in hertz. Hence, those are what? The units of what? Frequency. So now, guys, 6.4 for there. So now 6.4, I'm just gonna take it down. So this is 6.3. Let me remove those clumsy things there. So now 6.4. So now, guys, use the information in the graph to calculate. Let's check it for coding, okay? Use the information in the graph to calculate what? To calculate the speed of a car. To calculate the speed of the car, and take the speed of sound in the air as 340. You know that we are what? We are dealing with Doppler effect. Doppler effect says that the apparent change of a frequency detected by the listener, because the sound source and the listener have different velocity relative to what? To the medium sound propagation. So it means now we can use this formula. V listener is what? Is a velocity or the speed of sound in the air plus and minus the velocity of the listener all over the V plus and minus the velocity of what? Of the source multiplied by what? The frequency of what? Of the source. I'm going to show you this formula, how you'll find how where you should get this formula from. So now, are you seeing this? So now, this is sound wave. Sound wave, when you are dealing with Doppler effect, guys, always Doppler. Okay, Doppler effect. When you are dealing with Doppler effect, always check here for your formulas. These are the formulas. You can see frequency of the listener is the speed of sound in the air plus and minus velocity of the listener divided by the velocity or the speed of sound in the air plus and minus the velocity of what? Of the source multiplied by what? The frequency of the source. Understand? Let's go back there. So now we are here. No? We are here. So now we know detector P was what? Was inside the what? The police car. Was placed inside what? The police car. So you can say this is what? Detector what? P. So if it was placed inside the car, I told you before that the frequency of the source is equals to what? The frequency of a listener, which is what? Detector P. Let me show you where I wrote this. It's here. You see? It's here. So now let's go back there. So it means now, let's see for coding, okay? So now it means now they're saying we have to use the information to calculate the speed of the police car. This is the speed of sound in the air. This one, guys. This is the speed of a source, which is what? The police car. So it means now to find the frequency of the listener, we know where we have to find that from. Yeah? We know where to get that from, because now we cannot just use detector P alone. Because if we use detector P alone, the frequency of the source and the frequency of the listener, they're going to be the same. So, but we can take advantage of what? Of detector P, saying that they have the same frequency as the source, and then place it here. And then for the listener, we are just going to use the graph of what? Of detector Q. Understand? So we know that frequency, let me just write it like this so that it makes sense. The frequency of the listener, frequency of the source. Frequency of the listener, we know that FL is what? Is the same as 1 all over T. So this is 1 all over T, which is equals to what? We know that looking at what is this? The velocity of the listener. Remember, I'm saying we make use of what? Of detector Q, since we have what? The speed of the source. So it means our listener is going to be what? Is going to be our detector Q. But remember about the detector Q. Detector Q, we are told something here that it is placed next to the road. The meaning of placed is mean it is just standing there. So if something is just standing, what is the velocity there? It is not moving, it's not doing anything. So it is zero motion there. Now, so it means if it's zero motion there, this part, the velocity of the listener is going to forfeit there. It means you just have V into what? A V plus minus what? Vs multiplied by what? The frequency of the source. We can make the substitution ahead. So it means now this is 1 all over the t. This is the time it took to complete one full cycle. You go back there and say, the time it took to complete one full cycle is what? 18 times 10 to the power what? Negative 14. So this is what? 18 times 10 to the power negative 4, which is equals to what? The speed of sound in the air, this has to be 340 all over a V. Remember, before that, guys, this is the mistake that some of you will make. Now, will have made those mistakes. So there is a mark. You see, this 6 mark doesn't just come from anywhere, guys. It comes from the correct formula. And number 2, for choosing the correct sign, guys. So since we are looking at detector Q, what is happening to detector Q? We know detector Q is away from the source. Since it is away from the source, it means now this rule, this is my rule, use this rule to find the correct sign. You say something like this. You use the what? The listener rule. The listener rule at the top there is V plus minus VL. You focus on this. This is the listener rule. Call this the listener rule. And ask yourself, is your detector away or is the source approaching the listener? The answer is no. If it is not approaching the listener, it means now this has to be what? This has to be negative because it is what? Away. Understand? If you look at this, it has to be away. Since this is away, you remember, since you're using what? The Doppler effect, the signs can never be the same like that. So if the top part is negative, it means the bottom part has to be what? Positive there. So it means now this is what? 1 all over T, which is equals to what? V all over V plus what? Vs multiplied by what? The frequency of the source. You see, if it is moving away, the top part, you focus on the listener rule, the top part is going to be what? Negative. Since the frequency of what? Of the source is greater than the frequency of what? Of the listener. So if it is greater than the frequency of the listener, or let me just put it like this so that you can understand. The frequency of the listener, which is detector Q, is less than the frequency of the source. So it means now, if it is less than, just think of what? It is less. So if it is less, to make this less, you have to use what? A negative sign there. Understand? So now, at the top is negative sign, at the bottom is positive sign. But the reason why we didn't put that negative sign there, we know that the velocity of the listener initially is what? Is 0 there. Understand? So now, you have to check it for recording. So now, we can make the substitution ahead. So we're just going to say this is 1 all over, remember, 18 multiplied by 10 to the power negative 4. I told you that the total time it took to complete one full cycle. 1, 2, 3, 4, 5. Always number your graph, guys. So 10 to the power negative 4. So now, the speed of sound in the air, this is 340 all over 340 plus, we are looking for what? For Vs, the speed of what? Of the source, multiplied by the frequency of the source, which is what? This part there. But you can do it like this. This is the frequency of what? Of the source. Or again, you can just say this is 1 all over 17 times 10 the power minus 4. Because I told you we have to make use of the advantage that the frequency of the detector P, which is inside the projectile, is the same as the frequency of the source. So we go to the diagram of what detector P and say the time it took to complete one full cycle is 70 times 10 to the power negative 4. So that would be what the thing in there. Understand? Because even here, I will have I should have wrote this to be 1 all over T there. You understand? So now, what we are going to do is this. Let me see. Let me use black. No? So I'm just going to punch this value here, guys. No? So let me punch that value. So 1 all over 18 times 10 to the power minus 4. I'm getting 5.5. Let me keep it to 6 like that. And then it's equals to what? 340 all over 340 plus Vs multiply by what? I'm going to punch this side there. So 1 all over 17 times 10 to the power minus 4. So I have an answer of 588 and then what? 0.2352. It's just, let me just round it to 3 like that. So this is what we have there. So now, since this is what we have there, this is easy, guys. Now, some of you will say, this is a fraction. You say 1 times that, this times that. Guys, you have got this wrong. Let me multiply then. So we have something like this. So what we can do now is to say, all right, let's do the cross multiplication, or simply say this 588.2353 divided by 588.2353. This rationalize. We have this number 555.5556 all over 588.2353, which is equals to what? 340, which is equals to 340 plus Vs. So now let me see if I divide this big number by that 555.5556 divided by 588.2353. I have like 0.9444. Let me just keep it there, or 45 like that. Oh, so now I really made a mistakes. Let me just say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. How many fours do I have now? 1, 2, 3. I'm counting on my calculator. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then 5 like that. I'm just gonna keep it there, and then 3. I'm avoiding the thing of what, guys, of errors, né? So, and then what? 340 plus Vs. So all over 1, you times this there, you have 340, which is equals to 0.944445 multiplied by 340 plus Vs. Yeah, multiply by that. So now it's either you multiply here or simply do this in a wise way. Divide by 0.944 how many? 4, 1, 2, 3, 4, 5. Is it 4, 5? 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 4, 5. And then this 0.94. 1, 2, 3, 4, 5. 2, 3, 4, 5. And then like that. So now, see what you have now. You have what? 340 all over 0.94445, which is equal to what? 340 plus Vs. You take this to what? To the left. So you're going to have what? You're going to have what? You're going to have 340 all over 0.9444441234445. Subtract 340 is equals to the speed of our police car. So I'm just gonna say 340 divided by the answer minus 340. I have what? Vs to be 19. Let me just take this down. I have Vs to be 19.999. So I'm simply gonna round this to small places, which is going to give him which is going to give me what? 20 meters per second, like that. So this is the speed of what? Of the thing, guys. Let's go back there. Use the information in the graph to calculate the speed of a police car. So that's the speed of what? Of the police car, guys. So now let's take a look at the next question. Let's check it for coding. Okay. So now next question, question 7. This is what the electrostatics. So I'm just gonna name it here that this is electrostatics. So that's electrostatics. So now, guys, 7.1, they're telling us that a small sphere Y carrying an unknown charge is suspended at the end of a light inaccessible string which is attached to a fixed point. Another sphere X carrying a charge of what? Of what is this? Positive 6 times 10 to the power negative 6 there. So that's like what we call this? Is it a micro coulomb? 10 to the power 6 microcoulomb? Yeah, I think it's, yeah. This is microcoulomb. Yeah? So microcoulomb. So on an insulated stand is brought close to the sphere Y. Okay, it's brought close to the sphere Y. What do we know according to Coulomb's law? That when two charges are next to each other, they're going to express what? A force. So since they are brought to each other or close to each other there, we know that they are going to express what? A force. If I check, they say that a small sphere Y which is unknown, guys. Now it is brought close to what? To sphere Y. And then sphere Y experiences an electrostatic force and comes to rest to what? To 0.2 meters away. So what do you know according to Coulomb's law? Whenever the charges are next to each other, they experience a force. In this case, this is what? A repel force. This is going to that direction. And this, of course, went to that direction there. You see, the experience of force, or since it is only Y, it is means now this is positive and this has to be positive for it to go to that direction there. You see, it experiences a force of what? This is the force of X on what? On Y. Understand? So now they're saying with the string at an angle of 10 degrees with the vertical as shown in the diagram below. All right. Now, what is the nature of charge of sphere Y? Choose from positive to negative. I told you just now, guys, that according to Coulomb's law, when two charges are next to each other, they experience a force, and the force that we are seeing here has to be what? Oh, the force that we're seeing here, it is the repel force. Because now charge X is a positive charge. Charge Y is now being repelled to the west. This is telling us now the charge that Y is carrying is what? Is a positive charge. So that's what the answer there. So positive. Because it is being what? Repelled to the west. So now 7.1.2, calculate the magnitude of the charge on sphere Y if the magnitude of electrostatic force acting. Remember, I told you that according to Coulomb's law, when two charges are next to each other, they experience a force. And that force, we can calculate it by using what? By using F, which is equal to what? This is the electrostatic force, which is equal to what? K into Q1 times what? Q2 divided by what? By R squared. This r here, this is the distance between the two charge. In this case, is 0. What? 2 then. And in this case, again, guys, the magnitude of the electrostatic force, the force that they felt there, is what? Is 3.05. So we have that force. So this is 7.1.2. I'm answering now. So we have the force, which is what? The 3. Let me use another color, which is what? The 3.05, which is equal to what? The K there. K is 9 times 10 to the power 9. Let me show you. So now, this K is a Coulomb's constant. This is what? The K, which is what? 9 times 10 to the power 9 newtons per meter Coulomb there. Understand? So that's what? The Coulomb's constant. 9 times 10 to the power 9. Let's go back there. So we are back. So now, let me just write this here. Let me just take this down. So this is 3.05, which is equal to what? 9 times 10 to the power 9. Multiply by what? By the charge. We can name this to be our Q2, and then this is our Q1. Q1 is what? Is a positive 6 times 10 to the power negative 6 there. And then charge Q2, this is the one that we're looking for, and we can just call it Q there. Understand? All over R, I told you this is the distance between the two charges, which is what? 0.2 there. So this is what? 0.2, and then this is what? Squared. And always make sure that this radius there, or the distance that between those 2 points, is what? Is in meters. If it is, let's say it was 0.2 millimeters, you say that to convert to meters, you say what? 0.2 times 10 to the power what? Minus 3. This will be what? In meters. You understand? So now, let's see what we have. It's just the matter of what? Of calculations now. So it's just the measure of it's just the matter of algebra now. So I'm just going to multiply the top part there, like solve the top part. So what I have is what? Is 9 times 10 to the power 9 multiplied by 6 times 10 to the power negative 6. So what I have at the top is what? Is simply 5,000 or 54,000 actually, and then multiply by Q. So 0.2 squared, this is 0.004, 0.04. This is 3.015 divided by 1. So cross multiplication, this will be 554,000 Q, which is equals to 0.04 multiplied by 3.05. And I'm having a value of 0.122 divided by 54,000. So this the rational idea for the charge is what? Is let me see, answer divided by 54,000. This is giving me something there, so let me just round it. So I'm just gonna round it. So to round it, I'm just gonna say shift mode scientific and then press number 9. So the charge that it has there, it is 2.25. I wish I could like show you guys how I converted that, but you see shift and then what? Mode, and then you see you'll given a scientific there, then you place that number there. So if you still don't know how to convert, guys, just drop the comment. So now I have 2.6, and then this has to be what? Times 10 to the power minus 6. This is to be Coulomb, since we're talking about what? The charge which is measured in what? In Coulomb. So now 7.1.3, draw a elaborate free body diagram showing diagram for sphere Y. That's very simple, guys. Let's go back there. This is what? Is in equilibrium. This is what? In equilibrium. So this is what? The tension there. Why am I saying in equilibrium? Because they say it comes to rest. It means now everything is balanced there. It is what? It is balanced. So now the free body diagram there is going to be what? Remember, always there is what? There is gravity, the tension, and the force of what? Of X on what? On Y. So it means now our diagram here, I'm just going to take it to where it belongs. So we start by that dot showing that this is a free body diagram. And then you have what? The weight, the tension. Let me just write that down. Nice. So this is the tension. And then you have what? You have what? The force of what? Of X on Y. That's the answer, guys. I wish I can like just write it here. Force of X on Y. I hope you can see. Let me use red. Maybe red can look much better. So this is what the force of what? Of X on Y. The force of this X on what? On Y. So that's the free body diagram. This is the reason why it is 3 marks. They're going to mark here, mark here, mark here. You have what? 3 marks. So now calculate the magnitude of the tension in the string. This tension in the string. So now we need to use another method, which is called what? The SOHCAHTOA. Why am I saying SOHCAHTOA? When you see a triangle like that, we know this, they are going to make a 90 degree here. And now what you have here is what? It's a beautiful triangle there. So it means now using SOHCAHTOA to calculate that tension there, let's see which function are we going to use. Remember, this is the tension. Are you seeing that? This is what the tension. Let me use another color and click. So this is the tension there, which is what? The T. So to make sure or to be able to calculate that tension, we cannot use the vertical component because we don't know the mass of what? Of this sphere Y. But what we can do is to break this tension into its component. The horizontal component, which is going to give us what? T something, and the vertical component, which is going to give us T something. But let's figure that out. You just here, guys. This is not the same as Newton's. This is the same. This is not the same as Newton's. Yeah, this is not the same as what? As Newton's. You have to be careful here. So now, this is the angle. This is what? This is the angle. This is what you have here. This is the angle. So remember, the angle adjacent, or the side adjacent to your angle is called what? The adjacent. And we are looking for what? For the tension there. So it means now this is going to be what? The cos of what? Of the angle. This is equal to what? The adjacent side, which is going to be what? Remember, when you break this into its component, is Ty into Tx. Do we understand each other, guys? Because this is a horizontal plane, vertical plane, which is responsible for what? For Y. Understand? For what? For Y, guys. Make sure you understand that. Of course, this is also Newton's. I was just joking. This is what? Newton's. You can use Newton's knowledge here. Yeah? So cos of theta is the adjacent angle or adjacent side, which is what? Ty divided by what? The hypotenuse, which is what? The T there. You understand? So it means now doing the cross multiplication, you have what? You have T cos theta, which is equal to what? Is equal to T. And remember, this is Ty. And the Ty here, remember, this is Ty, in fact, this is Ty. So we cannot use Ty here because Ty we have to match it with that, which the weight. And the weight we can break it into what? Into mass and what? The grams. But we don't know the mass of what? Of this charge. So what we can do is to use the horizontal component. And again, you can break this into its horizontal component. The side opposite to your angle is called what? It's called the opposite. It's called what? The opposite. And we are looking for what? For the tension. So it means we are just going to use what? SOHCAH, because it's what? Not SOHCAH, SOHCAH, which is what? The opposite height, and then hypotenuse. So it means it's going to be what? Sine. Let me make sure that you understand this. So it's just going to be what? The sine of theta, which is equal to what? The side opposite to the angle, which is what? The Tx. So it means now to do the cross multiplication, Tx, not just Tx over what? Over T there. Because sine is what? Is opposite of what? Hypotenuse. And cos is simply what? adjacent of what? Hypotenuse. So now, do the cross multiplication, you have what? Tx, which is equals to what? T sine of what? Of theta. We can use this one and pair it with what? The force of x on y. You understand? So let me see if we can find the space down there. Let me just write it here. Né? You can see where this is coming from. So we're just going to see, okay, to calculate that tension, we're just going to say the sum, or let's say F net is equals to what? MA. We are using the second law, the Newton's second law. F net is equals to MA. But we know that they come to rest, meaning that they are balanced. Once this sphere sphere is able to stand to that distance is 0.2 meter, where there is whereas there is tension there, it means now this is what in equilibrium. It is what? It is balanced. You see, it is what? It is balanced. So it means since it is balanced, the F net has to be what? Has to be zero there. So the F net is what? Is zero. Understand? Since it is what? It is balanced. The F net is what? Is simply zero, guys. You understand? So now, since the F net is equal to zero, we can say the sum of Fx is equal to zero again. The sum of Fx, remember, so now we have what? We have a Tx this side. So it means we're just going to say what? We're just going to say, okay, this has to be what? This has to be Tx plus, this is the sum of the horizontal component, the horizontal component. Tx plus what? Oh, you have to choose. Remember, the force is in this direction. It means now this Tx has to be negative. Né? So it means it's going to be what? The force of x on y minus Tx is equal to 0. But when we solve for Tx, you find that this has to be what? Positive Tx. And Tx is the same as what? As T sine of what? Of theta. And the force is given to us. This is the force. This is what? The force. So this is what? 3.05. And the angle is given is what? Is 10. So divide both sides by sine of 10 degrees. Sine of what? 10 degrees. So this and this rationalizes. So therefore, the tension is what? So that's going to be what? 3.05 divided by the sine of 10. That's not 90, guys. Sine of what? Of 10 there. So let me remove this. Sine of 10 degrees. So let me remove, restart this calculator since it was on scientific. So 3.05 divided by what? By sine of 10. Sine of 10. Let me see what I'm getting there. So the answer that I have is 17.56 corrected to the decimal, and the tension is measured in what? In newtons. So this is what our answer. See how simple that it is. So it's very simple, né? So the tension is simply what? 17 point, what was that? 56 newtons. So newtons, like that. So now, guys, here I have to teach a lot. Yeah, let me see how long I'm. Close to 3 hours. Oh, okay. I'm so tired, but okay. Here I have to teach now, so that you understand what's going on here, because I'm preparing you guys. Remember, this is the opportunity that I have now, so I have to make sure I use it wisely, guys. I have to sacrifice what if I should have like I have to sacrifice my things, sacrifice my schedule, what? So to help you prepare, guys. So I have to make sure that I teach here so that you understand what's going on. You never get electrostatics wrong. Yeah? From now on, you understand electrostatics. You understand work energy and power. You understand projectile. You understand newtons. You understand Doppler effect. You understand? All right. So now, guys, 7.2. Two small charged spheres A and B on insulated stands with charges what? Let's highlight that. With charges 2 times that and charges what -4 into that. Respectively, are placed 0.2 apart, as shown in what the diagram below. M is the midpoint between the two, or between the spheres A and C. Now, this is called the electric field, guys, at a point. You can see we have what they're asking us to define. Let me use the highlighter. They want us to define what is electric field at a point. Electric field at a point, this is the electrostatic force experienced per unit positive or per unit test charge, or per unit positive test charge. Understand? I don't know if I got that wrong or what, but I'm really sure, guys. It is what? It is the electrostatic force experienced per unit what? Positive test charge. Understand? Per unit test charge or positive test charge. So make sure you check that if it is positive test charge or just per or electrostatic force experienced per unit test charge placed at that point. And I forget to say place that at that point. So you have to say this is the electrostatic force experienced per unit test charge placed at that point. In this case, you see, you have that test charge there. So now, we have those test charges. We have the charges together here. You can see we have what those charges. So now I define the electrostatic. What is this? I've already defined this. So we have those 2 marks. I said, what, guys? This is the electrostatic force experienced per unit per unit test charge placed at that point, or per unit positive test charge. You understand? Make sure you go to the what is this exam guideline and check carefully. Understand? Check carefully, but you'll never go wrong with this definition. It is fine. You can say per unit positive test charge, okay, or say per unit test charge placed at that point. Don't forget to say what? At that point. So I see I have read there. So let me make another. Let me make this to be that. So now, guys, I have to teach here. No? So electric field is like this. Electric field is this formula. This is the electric field. Electric field, guys, is what? Is the force exerted on a tiny test charge, that divided by what? By the magnitude of what? Of that test charge. That's what electric field at a point. It is what? The electro or the electric force exerted on a tiny test charge divided by what? The magnitude of what? The test charge. Remember, the force is measured in what? In newtons. The charge is measured in what? In coulombs. So it means now the unit of electric field is what? Is simply newtons per what? Per coulomb. Like that. Those are what? The units. So now, guys, another thing that you should know, guys, is that electric field at a point, or electric field, guys, is much, or is a vector, much like what? A force, which is what? A vector. So electric field is what? Is a vector, much like what? A force. Yeah. So now, the good thing about electric field, guys, is that it tells us how the electrostatic force or how the electrostatic force exerted at the what is this? The positive test charge and the negative test charge. You see, it tells us about how it tells us about what? About how the electrostatic force is experienced on what? On the test on the positive test charge and what? The negative test charge. So now, what about we put a positive test charge? If we put a positive test charge in the electric field, what happened to it? When we put a positive test charge in electric field, it's going to experience a force that will accelerate it in the same direction as what? As the electric field. So it's going to feel a force that will accelerate it to where? To the same direction as what? As the electric field there. Now, what about the negative test charge? When you place a negative test charge in an electric field, it's going to feel a force that will accelerate it in the opposite direction to the electric field. Make sure you understand that. When you place a positive test charge to an electric field, is going to experience a force that is going to accelerate it in the same direction as what your electric field. When you put a negative test charge, it is going to accelerate it in the opposite direction to what to your electric field, because your electric field is in that direction. Then a negative test charge is going to feel a force in the opposite what direction there. That's what a positive and a negative test charge. But it turns out that charges, guys, do create their own electric field. It turns out that charges do create their own electric field. So now let's say you have a positive test charge like this. Né? So when you have a positive test charge like this, it creates its own electric what field. So it creates its own electric field. This electric field is what is outside, or is going, or the electric field created by what, by the positive charge is extends, or it extends in all direction away from what, the charge, away from what, the test charge. So the electric field that is created by a positive charge is what, is it extends in all direction away from what, the test charge. What about a negative test charge? So now, when we have a negative test charge like this, let me just write it here. When you have a negative test charge like this, the electric field created by a negative test charge extends in all direction, but in this case, towards what? The test charge. It extends in all direction, but in this case, what? Towards what? The test charge. So the electric field created by a negative test charge is what? Is towards the test charge. So that's what you should know, guys. Understand? So now, let's say you have a charge like this, and then we want to determine the electric field at some point. Let's say at point A there, and we have a positive test charge at point what? At point A, a small tiny test charge. Remember before, when I introduced to this, I said that the electric field, this is what, this is the magnitude of what, of the electric force exerted on what, in on a tiny test charge. That's the force, the magnitude of the electrostatic force experienced or exerted on a what, tiny test charge, divided by what, by the magnitude of what, that test charge. So in this case, if we want to determine the electric field at some point, let's say A. So this A is our tiny test charge. It has to be what, less than what we have here. So this is what, so that it can balance each other. There. So that it can what, balance each other. So this is our charge Q, and our charge what, small q there. This is our tiny test charge. So now let's say that they are placed at some distance r there. So now, what do we know about a positive test charge? We know that a positive test charge, this what, or the electric field that is created by a positive charge extends what, away from what, from the test, from that test charge which is positive, towards what, our point of interest. So the electric field created created by what, by our positive test charge is what, towards the what, our point of interest, which is what, point Q there. You understand? So this is what the electric field experienced by what, or created by what, by positive test charge. It's always from the positive test charge, and then, or away from the test charge to what, to the point of interest. So now, to determine the electric field, guys, you simply do what, you simply draw an arrow from your positive test charge towards what, the point of interest, which is what, point A. So now, according to Coulomb's law, we know that when we, or when the two charges are next to each other, they experience what, a force. And we can be able to determine that force. But first thing first, when we place two like charges according to Coulomb's law, they will experience a force that is going to what? To repel them. So this is experience a force toward to the west, and then this will experience a force toward to the east, like that. And we can be able to determine what? That force by using what? By using this formula, which is what? There is this formula which is says that if you have like let's say you have F is what? Is K multiplied by what? By the Q times what? This tiny test charge there. Or I know guys, you guys know this formula. It says F is K into Q1 times Q2 divided by R squared. This is the same formula that I'm using. But in this case, I have a tiny test charge there. It is Q, small q there, divided by R squared. This R is the distance between what? Our two charges. The big Q and what? And small q. You understand? So we can be able to calculate what? That force there that is felt between what? Those two charges. But remember that F, we can replace now this entire equation, this part here, to where? To our place of what? Of what? Of F there. In the place of what? Of F there. So what we are going to do is this. You see what F is like. So E is gonna be what? E. You can write this E to be what? To be F all over 1 times what? 1 all over Q. This is the same thing. When you multiply, you're going to have the same thing. So now when we make the substitution there, I'm just gonna take it down. So it means I have E, which is equal to what? F all over 1 times 1 all over Q, like that. So if I make the substitution, look what's happening. F is the same as what? As K Q times what? Times small q all over what? All over R squared times 1 all over Q. But if you have to check, the Q at the top and the Q at the bottom, they rationalize each other. So it means now, therefore, that the equation that you have here, this is the equation that we are going to use to calculate the electric field at a point. Is what? Is K Q all over what? All over R squared. This is the equation that we are going to use. Well, let me just write it down so that you can see. I'm going to show you where it is in your formula. I just proved it right now. So I'm just going to show you where you find it in what? In your formula sheet. So now let me pause and show you. You see, isn't this the same formula, guys? This one, you can see it is the same formula. This is the formula that you will use to calculate what? The electric field at a point. The electric field at a point, you are interested to what? To your charge and the distance between those two charges, or the distance between the charge to your point of interest. Now let's go back there. So now we are here now. This is the formula that you're going to use to calculate what? The electric field. You understand? The K is a constant, which is what? What is this? The Coulomb constant. Yeah? The what? The Coulomb constant. So now coming back to the question, I told you that this is gonna be a long one because I have to teach you here. But I'm done with those teaching strategies. Remember, before the lesson, I told you that I have to what? Give you the strategy. Yeah? Give you what? The strategy. So this is the strategy. So now, look. Let's say in 7.2, again, we defined the electric field at the point. They said this is the electrostatic force experienced per unit positive test charge placed at that point. Yeah? So now, they say that two small charged sphere A and B on insulated stands with charges to that respectively are placed 0.4 meters apart as shown in the diagram below. M is the midpoint between the spheres A and B. Now we need to calculate the net electric field at point M. We need to calculate what? The net electric field at point A. Don't hesitate, guys. I got this. Don't hesitate. I got you, né? So we need to calculate what? The net electric field at point M. So it means now, remember our point of interest. Our point of interest here was what? Was A. So we asked ourselves, for us to calculate the what? The net electric field, what we need, or the force Q, we need to first determine what what is this? We need to determine the electric field experienced by each, or the electric field at each charge. Understand? We need to determine what the electric field at each test charge. So that's the first thing that we should do. We need to determine what the electric field at each test charge. So now, starting with A there. You see A, it has what? A positive test charge. Our point of interest is what? Is M, because they say calculate the net electric field at point M. It means now our point of interest is what? Is to the M there. So what happened? I told you that a positive test charge, or a charge, or charges do create their own electric field, which is when you have a positive test charge, it's going to create a electric field that extend in all direction away from what that test charge. That is going to create what? The electric field that extend in all direction away from that test charge. So, but look at this, what you have here. Our point of interest is M. We know that it extends in all directions. So it means to determine the electric field there, A is going to what? The electric field created by this A is going to be what? To the eastward. It's going to be directed eastward, and we can term that what? East 1. What about the negative test charge? I told you that whenever you have a negative test charge, it creates an electric field that extends in all direction towards what? The test charge. Towards what? The test charge. It extends in all direction towards what? The test charge. So if you are to check here, it is extending all direction towards what? Itself, which is what? The test charge. This is the negative test charge. So it means now B, since from M that this is our point of interest, is going to B is going to what? Is going to create an electric field that extend towards what? Itself, which is what? The negative test charge. So which is going to be what? E2. So now look what's happening. E2 is directed what? Eastwards. E1 is directed what? Eastwards. So at the center here, at the center, both E1 and E2, they are in a same direction. So now, when they are in the same direction, the net, which is called the E net, the net electric field is just what? The sum of the two electric field there, E1 plus what? Plus E2. That's how you determine what? The net electric field. First, you need to make sure that you have the direction of what? Of each electric field. So now, at the center, when we take a look at the center there at point M, E1 and E2, they are going where? They are in the same direction. So the net electric field is just what? The sum of what? Those electric field created by what? By E1 and what? And E2. So it means now we have a formula. E net, so this is 7.2 point what? Is it 7.2.2? Yes. So E net at point M is going to be what? E1 plus what? Plus E2. But what is E? E is the electric field, which is given by what? By this thing here. So it means we're just going to make a substitution and say E net is just going to be what? E1. This is K, Q, and then all over what? And say Q1 all over R squared, which is plus K, Q, Q, all over what? R squared. So now, E net, or I can just drop this for now. I'll bring this later. So we know that this is a Coulomb's constant, which is what? 9 times 10 to the power 9. The charge, let's go there. The charges is what? Is 2 times 10 to the power negative 5. 2 times 10 to the power negative 5. All over the distance. Be careful. What is the distance? The distance, this is the R is the distance between what? The two charges. But in this case, our point of interest is what? Is M. So what is the distance between A and M? It has to be half of what we have here because the total distance is what is 0.4. So you say the 0.4 divided by 2. That's to be what? 0 point something, which is 0.2. Now, it is what? 0.2. So that's the distance there. Be careful. That's what? The distance. So now, it means now this is 0.2 and then what? And then squared. Plus 9 times 10 to the power 9 into what? Let's go to the charge Q2. Q2, this is B, which is negative 4 times 10 to the power minus 5. You don't worry about substitution, about putting a negative there, guys. Don't put a negative to those formulas because now we know that the net the net electric field is what is to the right now. The net electric field is what is to the right because of what at the center here E1 and E2 is what is to the east. So now the net electric field is to the what? To the east also. So you don't worry about what? The negative sign there because now you have determined the direction of what? Of your electric field is to what? Eastward. So now make sure that you get right that one right. So this is 4 times 10 to the power minus 5. 4 times 10 to the power minus 5. All over the distance is going to be the same from the point of interest to what? To the charge. So now let me take out my calculator. So E net, which is the net electric field at point M. So I'm going to start with this part here. So this is what? 9 times 10 to the power 9 into 2 times 10 to the power minus 5 all over 0.2 squared. So here I get what? I get like 45 400 then what is this? This number is huge. So this is 400 what is this? 400 then this is 4 million, guys. 4 million. No? 4.5 million. So let me just jot it down like that. I have 0, I mean 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 8. Yeah. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, I have to make sure that I get that right. So now let's move to this part here. So this is 9 times 10 to the power 9. 4 times 10 to the power minus 5 all over 0.2 squared. So this is 9 million. So plus 9 million. 1, 2, 3, 4, 5, 6. Yes. So now let's sum those two plus 4.5 million. 0, 1, 2, 3, 4, 5. So the answer that I have is 13. What is this? Is 13.5 million. But I'm going to turn this into scientific. So the answer therefore E net at point M is going to be what? Is going to be 1.35 times 10 to the power 7. This has to be what? This has to be remember the units. If you have to check, you have what? You have what is this? The charge, the charge is in kilo. The distance, what is this? The distance is in meters, and then this is gonna be meter squared. That K, I think is like meter squared times Newton times into this. So I think this and this will rationalize. When you multiply these two, they're going to rationalize. So the answer is Newton. You see, because it is the force. The net electric field is what is a force. So let me show you how. So if you have to check here, you see you have what? You have Newton meter squared and that. You have what? Remember, it is that formula is E is equals to what? Is equals to KQ all over R squared. So K, which is the Coulomb's constant, is measured in what? In Newton times meter squared times into that. And then multiply by Coulomb again, but we can remove this and say multiply by Coulomb all over what? All over meter squared. Why meter squared? Because a radius is measured in meters, and then that squared will give you what? M squared. So the M squared and the M squared rationalize. So now, when you have the same base, this is the power of a product rule. Then the power of a product rule says if you have the same base like this, you add the exponent -2 plus 1, this will give you what? A -1. So it tells you now you have at the top you have Newton per into that. So this is what the what is this? This is the units, guys. So the units here is what? Is Newton per what? Into that. Of course, I shown you here that this is what? Newtons into that. Are we together, guys? Okay. So, guys, will you fail to get me to 100 subscribers? You won't, ne? So please make sure you get me to 100 subscribers. So make sure you support my channel so that I can help others next year's and also help you guys this year's. Ne? So make sure you hit that subscribe button and follow for more. Ne? So we are done, guys, with that thing. So that the net electric field. Ne? To what? To east, and you can see east. It's up to you guys. If they didn't specify, you can leave it there. If they say in the direction, you know it is what? Eastward. Because E1, because at the center there, E1 and E2, they are in the same direction. Understand? So now I'm just going to move to the next question. This is electrical circuits. Né? Let me just use red. Electrical circuits. One of the wonderful topic you can ever learn, guys. So now for the talking. Let me see if I'm recording all right. That's why I'm recording for you guys. All right. So in the circuit diagram below, resistor R with a resistance 5.6 ohms is connected together with a switch, an ammeter, and a high resistance voltmeter to a battery with unknown internal resistance. All right. The resistance of the connecting wires and the ammeter may be recorded. All right. So now you can see that the switch is open here. No? So now the graph below shows the potential difference across the terminal of the battery as a function of time. Okay. At time t1, this is time t1. Excuse, time t1, this is time t0. At time t1, switch S is closed. It means now from T0 up to T1, the switch was what? Was open. And then from T1 to there to up to infinity, and then it was what? It was closed. So now, guys, I'll show you how. Remember, when the switch is closed, the voltmeter reads what? The value of the EMF. Make sure you write that down. When the switch is open, the voltmeter reads what? The value of the EMF. I'm going to show you how. They say define the EMF of the battery. Do you still remember this formula? Hey, well, do you still remember the definition? Okay, let me see if I can remember the definition. So E is equals to V external plus V internal. Let me see if I can generate it from what is this? The definition then. So now it is V external plus V internal. So the EMF of the battery, guys, I think this is what is this? This is the this is the what is this? This is the I think it is the potential or the energy provided by the battery, or the total amount of energy provided by the battery per coulomb or unit of a charge passing through it. I think that was the definition as far as I can remember, guys. Now, EMF, this is what the total energy provided by what? By the battery per unit coulomb of charge passing through it. And make sure you check this definition. But I think I'm stating it right. If I'm stating it right, remind me in the comment section. I'm saying that EMF, this has to be what? The total energy provided by the battery per unit coulomb of charge passing through it. Ne? I hope you understand that. The magnitude or the total amount of energy provided by the battery per coulomb of charge passing through it. Yeah. So guys, I don't memorize formulas. I don't memorize definitions. Now, I just know them by like I don't memorize like just like to cram and stuff and see. So I'm able to derive them because I see it's V external plus what? V internal. So it has to be what? The total energy provided by what? By the battery. The V external plus the V internal a unit coulomb of what? Of charge passing through it. Understand? Okay, enough with that. So we know we have those 2 marks. And guys, I forgot. You should have said there that I don't know what was the total of that first question. I think maybe it was 16 or somewhere there. So take that value divided by 150, multiply it with what? With 100. Then multiply it with 100. So now, so 8.2, they're saying that we have to write down the value of the EMF. I told you that the value of the EMF when the switch is open, the voltmeter reads the value of what? Of the EMF. Why? Because there is no current flowing. Let me go back to the circuit. The switch is open. The current cannot flow from this point and then come to this point here. So there will be no current because of what? The switch is open. Remember, we get V lost. V lost start to happen, which is V lost. Remember, this is the V internal, which is what IR. V lost start to reduce our voltmeter when there is current flowing because it depends on what? On current. Once there is no current flowing, it means now, check. It means now this is the V external, which is what? The total voltage plus V internal. Once there's no current flowing, current is 0. So once current is 0, this value becomes 0. So check. E is equal to what? V external. The total voltage is equal to that. So if you have to check there, when the switch is closed, this is when the switch is closed. This is the value when the switch is open, not closed. This is the value when the switch is open. So it means now the V external is 13, which is going to be equal to what? The EMF, which is the electromotive force measured in what? In voltage. Everyone? So that's the total voltage provided what? By the battery per unit coulomb of charge passing through it. So you see how to get that value. When the switch is open, always know that the voltmeter measures what? The value of the EMF then. So that's our answer then. So it means now I have 2 marks of this. And then this is write down the value. This is the EMF is what? Is simply 13 volts. And then we have that mark again. So let me make this nice. You have that mark again, which is what? 1 mark. So now, switch S is closed. You see now the switch is closed. It means now the voltage that you are going to have is this. Why? Now you see the voltage decreased from 13 to what? To 10.5. What happened? Because there is current flowing. Once there is current flowing, we are going to lose some of the voltage in the what? In the circuit. And that the lost voltage is due to what? To the V internal. You see? So now they're saying that 8.3.1, when the switch is closed, calculate that the current through the resistor R. That's very simple, guys. We are going to use this small triangle, the Coulomb's law triangle, which obeys Ohm's law. So this is the I, the R, and then what? The voltage. So we are looking for what? For the current through resistor R. So it means now, using this triangle, we can have many formulas here. We can say that V is equal to what? I multiplied by what? By R. And we can also say that I is simply what? Is simply the voltage at the top divided by what? The resistor at the bottom. And we can also use R to say R is simply what? The voltage at the top divided by what? By the current at the bottom. We are looking for what? The current through resistor what? R, which is what? Which is given. So now we have resistor R 5.6. So we're just going to say, okay, I is simply what? V over R. The voltage is not going to be 13, guys. It's going to be what? 10.5, because this is the one that is provided to what? To that resistor. Understand? So that's 10.5 all over the resistor. Let me check. 5.6. So divided by 5.6, which is equals to, let me check out my calculator. 10.5 divided by 5.6. Hey, my calculator is in scientific. So let me format that. So this is 10.5 divided by 5.6. So the current that we have here is 8.875. But round to this two decimal places, you read the instructions. So this is 1.88 amperes. So that's the current. So now we have what? Those 3 marks. Where are those 3 marks coming from? From the formula to substitution to your final answer and your units. So what is 3 marks, guys? Always what? Remember that. So now 8.3.2, the power dissipated in the resistor R. The power dissipated in resistor R. And again, there is this formula for power. It says P, I, and then R. Like that. You say what? P, so it means you're going to say P is simply what? Is simply I times what? R. Understand? But what is I? We know that I is simply what? This part here. So I'm just going to make the substitution. You see, I'm discovering I'm inverting the formulas now for you to show you. Again, I told you I'm going to show you the strategy. So I is simply V over R. So this is what? V all over R. Multiply by what? By what is this? Multiply by what? The R. So now, what do we have here? It seems like the R and the R are rationalizing each other, but we cannot use this formula here. No? So let me see. If I say what is this? I have to make the substitution, no? But I know this is P into what? Into I times what? The R there. So now, when I make the substitution, I'm going to say what? I'm going to say that, okay, we know R is what? Is V over I. Even this one is going to rationalize. I don't know if I made a mistake of this or what. But okay, let's check the equations in the formula sheet. I'm going to show you how to invert that, how to come up with this formula using the triangle. So now here we are, guys. Take a look at this. This is PVI. So it means now if it is PVI, me now myself personally, I made a mistake. This is P into what? VI, not R here. We don't have what? R. So R is replaced by what? By V, and V is replaced by what? By P there. So it means it is PVI. So I'm going to invert those formulas for you. Let's go back there. Okay, so we are back, guys. So you saw what happened there. So it means now our triangle is simply like this. It's simply P into V and I. So it means now the power dissipated is what? Is the voltage times what? The current. But what is the we can create any formula that we want here. Voltage is simply what? Voltage is simply I. Let me make the substitution so they can see. Simply I multiplied by R, and then times what? The I. So the I there is going to be what? So this is the first formula. So P is simply what? I squared times what? The R. The second formula is going to be what? Using this one that we have here, just making the substitution. So now, what is what is this? The current. We make the substitution using the current. The current is simply what? V all over R there. So let me make the substitution so that you can see V over R. So now, it means now our formula is going to be what? P is simply what? V squared all over R. This is the first formula. Actually, the second formula, the third formula. You see, you have those formulas. This one, these ones, and this one. If I go there, you'll see them, guys. Let's go there. So here we are, guys. You see, this is the first what formula. This is the second formula. This is the third formula. You see, you have what V R. You have V squared I squared V I like that. So we're just going to use those formulas. Now let's go back there. So now here we are. Now, so you see V squared I squared into that. So we need what? We need the power dissipated in resistor R. So in resistor what? In resistor R. It's either we use what is this? The first formula, the second formula, or the third formula. So I'm answering this one here. So I'm just going to use the second one formula there, which is V squared all over R. The V squared is simply 10.5 squared all over the resistor R, which is like 5.6. Here it is. So it means now, let me see what I have. So I have to confirm, guys, also using those formulas so that you are sure when you're in this exam room. So I get a value like 19.6 9, and then power is measured in what? In watts. Let's use we use equation what? Number what is this? Equation number 3. So now let's use this one here and see if it will work. So this is P. The current we know it is 1.88, the one that we calculated, and the resistor that we're focusing on is what? Is 5.6, which is resistor R. So now 1.88 times 5.6. The answer, what is this? I have like I see I missed the squared. So 1.88 squared multiplied by 5.6. So the answer is simply 19.79 watts. So you can see, guys, that of course you will be given a range that your answer should be 19 up to 20 or something like that. You see? Even if you use this one, guys, it will still works. Just try on your own and see. It will still work, but we are done with that. So now let's take a look at the next question. So 8.33, internal resistance R of a battery. We know that EMF, or I can say just E, is the same as what? The V external, excuse, plus what? The V internal. The V internal is what? The internal voltage, the external voltage. This is the one that supplies the circuit externally. This one that's this one is the one that is lost inside what? The battery. So we are looking at the internal resistance, which is R. So which means we have to break this formula. So it means the what is this? The EMF is gonna be what? The V external. But what about the V internal? You know that from the Coulomb's law, you have VIR. So it means it's gonna be what? I multiplied by what? But in this case, small r, because it is what? The internal resistance, not just the resistor anyhow, guys. It is the internal resistance. It's the one that what is this? It's the one that resist the current to flow, or I can say this the one that causes the voltage to decrease and so on. You see, the internal voltage, the internal resistance, and so on and so on. So yeah, that's a lot there, just. So now you cannot just divide anyhow, guys. Remember, there is a mark for correct formula, mark for substitution. So let's first make a substitution. We know that the EMF is 13. Now, since the switch was closed, the switch was open, the voltage read the value of what? The EMF. The voltage is what? Is 10.5. Plus the current is given, which is not given. We calculated it to be 1.88. It's here, guys. You can see this one. And then we're looking for what? Internal resistance. So what you can do do not divide here, guys, because there is a mark for what? For substitution. So what you could do to avoid being what is this? Penalized is to say that now 13 minus, you take this to what? To the left, you left 13 minus 10.5, which is equals to what? 1.8. Yeah, from after this part, after this one and write this one, now you can divide everything, guys. You see, because now you get the mark for correct substitution. So do not just divide here. I'm helping you so that, guys, you don't lose marks. You can know everything, like how things flow, but get there when now you just wanna rush, or like you don't want to spend time and stuff. That's fine, but if you're skipping those steps like this, you are going to lose marks. First, make sure you substitute everything. After substituting everything, you'll divide after, because there is this teacher that once told me. I remember it was final. Said, not final, it was trial. Ne? We're on this enrichment classes, and he said, okay, you shouldn't just divide exactly here, like directly here, because there is a mark for substitution. So make sure you divide after you have what? After making the substitution, make sure you write something after that, and then divide your answers there. So that I can get that mark. So now 13, sometimes they don't penalize, guys. You see, it depends on the examiner or the exam markers, like that. So now, therefore, the internal resistance is going to be what? 1.33 ohms. So that's the answer. So now let's take a look at the next question. So I know we are not done here, because you can see we don't have the total mark. So it means now we have to continue here. So two identical resistors, each with the resistance X. Let me see if I'm coding. X are now connected in the same circuit with switch S closed. Yeah? With what? With switch S closed, as shown below. So now they are saying that the reading, what is this? The ammeter reading now increases to 4 amperes. Wow. So now let me bring that formula. EMF, hey, seems like energy, no? EMF is simply what? Write it like this, guys. Symbol like this. Now EMF is something like this. And then this is the electromotive force. It's what? The V external, the external voltage plus what? The internal voltage. So now they're saying 8.4.1. How will the voltage reading change? Choose from increasing, or remain the same. Then how will the voltmeter reading change? So remember, I told you I have to teach you what the strategy. I'm showing you the strategy. So guys, EMF works like this. Now, this is the total voltage that you will find. You'll get, even you go to the shop, you'll get this is that one which is written there. You see that one that is written there, that is written 12. So that's what the electromotive force. But once you start using your battery, you'll find that when you measure your battery there using the volt or voltage meter or voltage measurement or something like that, so you find that the value of the voltage decreases. The reason is because of what? Of the V internal. But I'm going to show you how now. So now EMF is like this. This is a constant. EMF is a constant. It doesn't change, guys. It doesn't matter whether it's internal or what. It doesn't change this one. The only one that changes is this one. Eh? So now, I want you to think of EMF as like you have 10. That's your final answer, 10. So it means the summation of these two has to give you what? 10. So it means now the V external, maybe it is 5. So to balance so that we can get to 10, it means we need what? We need 5 again. Or if we have 6 for V external, it means V external has to be what? 4. So that it has to balance. When you sum these, it has to give us 10. You shouldn't have something like 5. Now this is a lot. This is 11. And 11 is not the same as what? As 10. That's how you deal with these questions. So you say, they say, will the voltmeter reading increase or what? Remember that EMF is like that, the main constant. This is V external. But what is V internal? V internal is the current, is the same as I times what? The small r. When the what is this? Remember, V internal is what is I small r. When the current increases from 1.88 to what to 4 amperes. You can see. So if this value increases, what happened to this part here? It increases also, which is going to increase what? Your V external. So it means now your V external does what? Your V external increases. Once your V external increases, remember I shown you using this example that it is what is 5 and 5. It has to balance. So now the V external increases. Let's say it is like 7. To balance this issue here, it means this one has to decrease. Decrease by how many? It has to decrease by what? By 2. Not by 2. Yes, it has to decrease by 2. So 5 minus 2 has to be what? Has to be 3. So that when you add these things, these two they can give you what? 10. 7 plus 3, that's 10. So it means the V external decreases. So which is what the voltmeter. So the answer is what? Is decreases. You see how simple this is, guys? So it decreases. There's a given reason for the answer by referring to V internal. So you're just going to say V internal resistance increases. You saw that it increases. Increases. So it's that. That's the answer. So now 4. Let's see. I'm recording. Okay. 8.4.2, calculate the resistance X. The resistance X, you remember, you are told that you have two identical what? Identical resistors. So those two identical resistors, they're in what? They're in series. Né? So to make them to be or to make them into one resistor, you have to what? You have to sum them using the R series, which is equal to what? R1 plus what? R2, because it's the same current that flows through this resistor. So when you sum them, since this one is the identical resistor, you'll have what? Just 2x. And then now you have what there at the bottom? You have resistor R there, which is 5.6. So now look what's happening. These two now are in what? Are in parallel. So you have to use that formula R parallel is equal to what? 1 all over R1 plus 1 all over R2. Or as I know there is someone who knows this formula, that R parallel is simply R1 times R2 all over R1 plus R2. You can use this formula to calculate R parallel. But in this case, I'm just going to stick to this one. So now, the R parallel is going to be what? The summation of this using the formula R parallel. But what's that R parallel? Since you remember, we have to turn this into what? Into one resistor. We have to turn this into what? Into one resistor, R, to be like that. So if we turn this into one resistor, it means that's what? The external resistance. That's the total resistance of what? Of our circuit. So to find that external resistance of our circuit, we're just going to use this formula up here. We're just going to say, okay, EMF is simply what? V external plus V internal, and we know that V external is simply what? I big R plus what? This big R is the external, the current is what? The I total, and then plus what? Plus the V internal. Since we don't know V internal here, we can simply say, okay, this is simply R into small r. So now you can see that you have II. That's what our effect. So you simply say this is I into what? Into I, and then what? R plus what? The small r there. The EMF is 13. It won't change this one. The current, remember the current increases to 4 amperes. So we are going to place 4 here. I'm now going to place 1.8. The R here we're looking for, this is the R external. Now that's going to give us R parallel. Plus the internal resistance. Even this one, guys, the internal resistance is not going to change, guys. Now, that one that we got there, the internal resistance that we were using there, let me go back there. So that internal resistance, it was what? It was 1.33. This is the one that we are going to use there. So 1.33 there. So now You'll say what? You divide. Okay, remember I said you don't divide here. So you'll say what? You'll say, okay, I have 13. This times that inside you'll have 4 are external plus, let me see, 4 multiplied by 1.33. I have 5.32. You take this to what? To your left. So now 13 minus the answer, I have 7.68, which is equals to 4 are external. Divide by 4, divide by 4. This rationalize, therefore R external is simply what? Is simply let me see, answer divided by 4. R external is simply 1.92. You are not done, guys. Ne? So this is the R external. Now we are going to bring that formula back. That to calculate the R parallel, we simply say this is 1 all over R1 plus 1 all over what? R2. Ne? So now 1 all over R parallel. R parallel is that one that we made it to be a 1 resistor. That's the external what is this? External resistance. In this case, it's just gonna be the same as that. So that's the total resistance in our circuit. So 9.2, which is equals to what? 1 all over R1. R1 didn't change, it's 5.6. You can see it's there, but R2 is going to be 2x. Since you just sum those two to make them to be the same or to be in parallel with what? The R of 5.6 resistor. So now you have 5.6 plus 1 all over what? 2x. Over what? All over 2x. So now you're just gonna say, all right, now to deal with this, guys, you need algebra here. If you don't know your maths is poor or your maths skills are slow, you won't able to solve this. I'm telling you, you won't able to solve this. Yeah? But what you can do is this. There are two different ways you can deal with this. You can take this to that, blah 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 and stuff. But let me just make your life easy. We have to make these two to have the same denominator. Yeah? To have what? A common denominator. So we have to find the common denominator there. So keep this one. To find the common denominator, we have to multiply this one here, top and bottom, by what? By this number, 5.6 all over 5.6. This is a cheating code in mathematics and physics. You come up with something. We know that this divided by this will give us 1. 1 times this is the same as 1 over 2x. Seems like we have done nothing, but mathematically we know that that is what our cheating code. And then multiply this part here by what? By 2x, top and bottom. So it means at the top you have what? You have 2x. At the bottom you have what? You have 5.6 times 2. 5.6 times 2. That's 11.2. So 11.2x plus what? 11.2x. You see, now we have the common denominator. And this is 5.6. So since we have the common denominator, we can simply make it our denominator there, and then sum the top part and the top part there, and then you have 1 over 1.92. Of course, you can simply do the cross multiplication here. So to do the cross multiplication, this is going to be this number times that one there. So you'll have 2x plus 5.6, which is equals to 11.2x. So now to make your life easier, or you can just simply multiply inside. So 1.92 multiplied by 2, you have 3.84x plus 1.92 multiplied by 5.6. You have 10.752, which is equals to 11.2x. The x and the x has to be in the same, what is this? They have to be in the same place. They have to be what? In the same place. So what we can do here is this. Since they have to be in the same place, you take this to what? To your left there. So it means this side you're left with what? 10.752, which is equals to 11.2 subtract 3.84. You left what? You left 7.36. X, don't forget, divide by 7.36. You see, that's why I say you need your methods to be strong here, guys. There's a lot of calculations, as if you're writing math. So therefore, X is simply what? Is simply 10.752 divided by what? By 7.36. So now our X is what? Is 1. Is not 4, is 1.46, and that's what they were looking for. Let's go back there. Calculate the resistance X. They are telling you that it is a resistance. So it means you have to put units, guys. You don't just say X is equals to. So X has to be this 1.46. And of course, if you wanted to find the combination of those two, if now you have 1 point, what is this? If you wanted to remember, the combination of those two gave us 2x. So to find the combination of those two, you put that 4.6 there, which is going to give you what? Times 2, which is going to give you 2.92. You see? So if you didn't like sum those two together, your answer would be 2.92, and then you'll have to divide by what? By 2, so that you get what? The x, since they are what? They're identical. So that's our answer, guys. So that's it. So again, you see this is 19, so 19 all over 150 times 100. Tell us what we got there. Okay, so guys, what is this? This is what electrodynamics. Again, this is a wonderful topic. You don't want to lose marks here, because these are free marks, guys. Let me see if I'm recording. For 4 hours, you guys gonna watch and learn. I'm telling you, you'll be ready if you watch this video up to the end. Okay, a simplified diagram of an electric generator is shown below when the coil is rotated with a constant speed. You see, guys, they're saying an EMF is induced. What is the meaning of induced? What is the meaning of induced? Induced means what? To generate. So since there is ED, it means now generated. So the EMF is what? Is generated. How is the EMF generated? When the coil is rotated, it induces what? It induces EMF, meaning it creates what? Or it generates EMF, which is what? The electromotive force. Remember that EMF is what? According to what is this? Faraday's law. EMF is what? Is number of coils multiplied by the change in what? In a magnetic flux. Multiplied by what? The change in a magnetic what? Flux over what? Over time. So now, as you increase the number of coils, what happens? There is a change in what? In magnetic flux. And once there is a change in magnetic flux as time proceeds, this induces what? Current. Or this not current. This induces what? Yes, it induces current. This induces what? The EMF. Which is what? The electromotive force. It generates what? The EMF there. So now, before we answer, guys, what do we call these things? These are called the carbon brushes. They're called what? The carbon brushes. And what do we call these rings? We call them the split rings, because you can see there is what? It is open here. You can put like a paper inside there, since it is what? Open, just by entering or trying to insert your paper like that here. You can move your paper like that. So they are called what? Split rings. Once you have your rings to be like that, they are called what? Split rings. So these are called what? Split rings commutators. So is it an AC or DC generator? It is a DC. How? It's easy to see to tell if it's a DC, because DC is like this. You have split rings. Your splitting rings are like this. So An easy way to understand this is to simply put a D there. And if you put a D, say now this is what CD, and this is the same as CD, this is the same thing. So this is what? An DC generator. So it is what? DC generator, because of what? Those three rings. So now, briefly explain how an EMF is induced. Briefly explain how an EMF is generated. You see, I told you that induced means what? To generate. Now they're asking you about that question, and I've already answered you. Briefly explain how an EMF is generated in the coil when the coil is rotated by referring to the principle of electromagnetic induction. So I'm just going to say that EMF is induced. Is induced by what? By what is this? The number of coil, or by the change, by the change in magnetic flux. Magnetic flux. Once there is a change in magnetic flux, remember that formula. Let me just write that nice. Once there is a change in magnetic flux, it induces what? The EMF. You see, it induces what? The EMF. So EMF is induced by the change in magnetic flux during what? Or during the coil, or when the coil, or when it is coiling like that. So EMF is induced by the change in magnetic flux as what? As it coils like that, as it rotates. So you can get your answer here again. So when the coil is rotated with a constant speed, an EMF is induced, you see, in the coil. So the EMF is induced by the change in magnetic flux in what? In the coil. Trust me, they will mark you guys. This is the perfect answer. So now, let's say draw a sketch graph of the output voltage versus what? The time for the generator. So now, since we managed to find that this is a DC generator. What is DC? DC means direct current. Yeah? So DC means what? Direct current. So I'm just going to answer is here 1.1.3. DC, guys, I'm just writing here that you understand. DC means what? Direct current. What is the meaning of direct current? It means now the current is not changing what? Direction. So they're asking us to draw that graph there versus time. So voltage versus time. Wow. Okay, let me just do like that. Then like that. We know that x-axis is always what? It's always time in what? In second. And then of course this will be a voltage of volts, meter, volt, meter. Let me check the spelling there. Draw a sketch diagram output of a voltage versus time. So I can say voltage, né? So voltage. Voltage is measured in what? In volts. Let me just make a space. So this is a voltage in volts. This is 0 here. So now, DC generator, the graph is what is going. Okay, let's go back and read again. Draw a sketch graph of output voltage versus time for this generator. You see, it's very important, guys. Examiners don't just wanna decorate questions. They're not decorating here, guys. This is very important. You see, if you miss this statement, then you are going to get 0. I'm telling you. So make sure you read the whole question. They say show one complete full cycle. I told you about one complete full cycle when we did that Doppler effect. So now, remember, since we're dealing with DC, this is a direct current. It means the current is not changing direction. So it means the graph is just gonna be what? Like that. That's a half. This is half, guys. Another one is going to give us what? One full cycle. Let's number this and so that I can tell you how. This is 1, 2, 3, 4, 5. You see, nothing is changing. The same way I taught you when we did that Doppler effect thing is the same thing. That's one full cycle. So guys, what if this thing was AC generated? How were you going to draw the graph? The graph for the time, and then versus the voltage of a AC, guys. This is what, this is something like this. It goes like that, reach the maximum height, and then like that, and then what, like that. That's a one full cycle. Let's count: 1, 2, 3, 4, 5. So you see, that's what a AC generator. AC generator says alternating current, meaning the current alternate, it changes, guys. You see, but we were not asked to draw that thing, so let's keep this real. Né? So this is 9.1.3. So that's the answer there, guys. It falls like that. Don't forget to get to know. Let's say there's a 4 full cycle, so you have to number 1, 2, 3, 4, 5. When you reach 5, that's one full cycle. Understand? Okay. I'm tired. You. So now 9.2, guys. 9.2. They say that a 200 what is this? 200 ohms. Am I recording? 200 ohms resistor is connected to a DC voltage supply. They're saying what? A 200 ohms resistor is connected to a DC voltage supply as shown in the diagram A. As shown in what? In the diagram A. So now they are saying that the energy dissipated in the what? What is this? In the resistor, in the resistor in 10 seconds is what? Is 500 joules. Okay. The same resistance is now connected to an AC source. Okay. Diagram, what is this? Diagram B. Okay. And the 500 joule of energy is also dissipated in 10 seconds. Okay. That's enough information that they gave us there. So now, define the term RMS of a voltage. You guys, what is the meaning of RMS? You find that someone now you are going to write your final exam, but you don't even know what is RMS. Guys, RMS, this is the root mean square. You heard what I said? Root mean square. That's what RMS voltage, the root mean square of a voltage, meaning that you have what? A square root like that, the square root of 2, root mean square of a voltage. That's why you find that RMS is equal to what? Is equal to I max divided by what? By the root 2. Like that. This is IRMS is what? Is the I max divided by what? By the root 2 there. That's why it's called what? Root mean there. Okay. So now they say define the root mean squared of a source of AC. So the root mean square of a source of AC, guys. This is what? This is the potential difference. The potential difference that that dissipate the same amount of energy as what? As DC. You get what I said? The potential difference that dissipate the same amount of energy as what? As DC. Make sure you understand that. Otherwise, you lose that 2 marks. You see how I know these formulas, guys? And then there is you. You don't know the formulas. Guys, let's be real. Know your formulas after watching this lesson. Oh, yes. During this lesson, guys, make sure you have what? The exam guideline. You are checking those formulas. You see, you are jotting them down. You are memorizing them. You are memorizing what? Those formulas. So that we are ready for the exam, guys. Please, I beg you. Yeah? The root mean of a voltage of its AC, this is what? The potential difference the potential difference that dissipate the same amount of what? The same amount of energy as what? As DC. Okay. So make sure you check that formula, guys. Then, so now 9.2.2, calculate what? The maximum peak voltage of the AC source. Yeah, this one I forgot the formulas, guys, but I'm going to show you where, because now we have the exam guideline. Not the exam guideline, we have what is this? We have the formula sheet. We are just going to go there to the formula sheet and pick those formulas. Understand? So this way we have to calculate what? The maximum peak voltage is what? Of AC. This is AC, guys. Be careful. Now, this is what DC source. This is what AC source. So now let's go there and deal with those formulas. So we are here, guys. These are the formulas. Name alternating current. This is AC. AC, alternating current. This is you can only calculate those things, guys, based on AC, not DC. Né? So now we need these formulas. Né? If we can like memorize them fast now, so you see, we have to calculate what? The I max. We need what? The I max. So to calculate, for us to calculate the I max, first we need to get what? This part. So to get that part, we'll have to use this formula here. You see this one? So if we can use this formula here, get this value, take this value, put it here. After putting there, get this what? A value there. What? The I max. You understand? You can either use this formula and then use this formula. You plug it where are you going to plug it? If you use this one, let me see. If you use this one is not gonna work. Oh, is it gonna work? Yes, it will gonna work. Yeah, it was gonna work. Yeah, yeah, it is going to work. I'm telling you. So now let's go there and check. So now remember, we are here to check. They say calculate the maximum peak voltage. Oh, the V max, guys. You see, they're looking for what? V max. Let's go back there. So look at this, guys. Now they're looking for what? For V max. So for us to calculate the V max, we can use any of these formulas here. Guys, you see, this triangle is going to help you find these formulas because it's the same thing. You just put the PA, IMAX, VMAX, VR means what. But since you'll be given the formula sheet. Don't worry, guys. Don't panic. You'll be given this formula sheet. So what we are going to do is that we know do we know the current there? It doesn't matter. But okay, we have these formulas now. So I'm just gonna memorize these formulas fast. This is PF is equals to VI. Okay, I'm not gonna memorize it because I know that I have it here. I'm just gonna say this is VRMS and then VRMS. So VRMS and then this part is going to be RMS and then RMS and then like that. And then let me memorize even this one. So this one I know this by heart. So this one, to calculate this one, we'll say what? To find this one, wait, if I can find this one here, get this I value, take that I value, place it there, and then what? From there, I can be able, will I be able to find that thing, guys? It's not gonna be, possible, né? So now, let's go back there. So it's fine. So I know I'm just gonna write this formulas down so that we don't waste time going there and there. You see? So it's VRMS multiplied by IRMS. So let me bring my thing here. So it was VI. So now another thing that I can generate is P. Okay, I have to combine this VIR. So I have V, which is equals to IR, I is equals to VR, and then R, which is equals to VI. So now I'm just going to combine them here. So PF is going to give me what? When I replace in the place of V, I'm going to get what? I squared RMS times what? The R. And then number 2 equation, this is 1, 2, 3, like that. PF is equals to, I'm going to replace in the place of I. So if I replace in the place of I have V times V, it's going to give me V total, V, what is this? V squared RMS all over what? All over I. And this I think is RMS. So, and again, there is this formula there that I showed is IRMS is equals to what? I max all over what? The square root of 2. And again, there's this one that VR ms is equals to what? Is equals to v max all over what? All over, what was that? I think it's root 2. Let me confirm. So yes, is v all over root 2. So now you see we have all of them there. Oh, the last one is r, not I. I'll fix that. It is r because I see I have what? I have the r there. So now let's go back there. So we are here. Am I still recording? All right. So I said I have to fix this one. So it is what? It is r. Because why is it r? Because I don't replace in the place of r there. Only this that I can replace. I replace in the place of I with v over r. So this is exactly what I have to do. So now enough with the talking, guys. So calculate the maximum peak voltage of AC blah 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 blah. Remember, we are given what? We are given power. We are given what? We are given time, and we are given what? The resistor R. So we have the power to calculate. We have we now have what is this? We have everything that we need. So now we're just gonna start here. Do we know the voltage? We don't know the voltage because they're saying that 200 resistor is connected to a DC voltage. We don't know what the voltage. I'm not gonna use this one. So now let me just use another color. I'm not gonna use the first one, because I don't know the either the. Oh, let me just erase that because I need that. I can use that thing to place it there, calculate that thing. Understand? Alrighty. So now, this is what we are going to do, guys. So we're just going to say, okay, we can start with that one there. So P, A, which is the average power, is simply what? Is simply V R M S times what? The I R M S. So now, what we are going to do is that power. What is power? Power is the rate at which work is done. Yeah? It's the power is the rate at which work is done. So we're just going to say, okay, this is what. Let's go back there. We are given that this is 500 joules. All over what? All over change in time. So remember that work is measured in what? In joules, and that is in joules there, and this is in second. So we can make the substitution 500 divided by 10. Or I can say power is the same as W all over change in T, which is equals to what? V R M S times what? I R M S. You're not given power. You see someone replacing, substituting the place of P average with the value of 500 joules. Guys, power is measured in watts. Do you see watts here? There is watts here? No. You see? Don't make me silly mistakes now. So this is 500. Hey, this is 500 all over 10 because that's 10 seconds. We are looking for this. We can say V R M S. Are we given the current? Let me check if we have the current. Current. The resistor connected to the voltage. What? We don't. Either we don't. What is this? We are not even given the RMS, guys. But what I can do, guys, sorry for that. I forgot we are not given that thing. Let's start here. Let's make these formulas. Let's use these formulas. Let's start there. This is P. Hey, this is P average. It's equals to what? It's equals to I squared RMS times the resistor. Why resistor? Because we're given the resistor there. You see, let's make use of that advantage. So power is the rate at which work is done, which is equals to I R M S squared times R. So now what is it? Work is 500 joules. The time is 10 seconds. We're looking for I R M S squared. Resistor is what? Is 200 ohms. Divide by 200. Divide by 200. Remember, so you shouldn't divide here. So now let's first get an answer from 500 divided by 10. We know this and this rationalize. So it means we have 50. We have 50. Now we have 50. And then I'll divide that by 200. So I have to take that thing to that. So first, let me just write this nice so you guys I'm so tired, guys. I'm telling you, I feel pain. So my body is tired, especially Mzimba. Just kidding. So now, what is that? 5 divided by 20. This is 0.25, which is equals to I squared RMS. So now, let's see what we have there. So we need to square both sides, square the answer so that this and this rationalize. So therefore, I RMS is simply what? Let me see. The square root of the answer is 0.5. I is measured in what? In ohms. Né? So this has to be in ohms. Ohms, this is amperes. Guys. Am I crazy? Because this current is measured in in amperes. You see, I keep repeating the ohms. Sorry for that. So now we have the I root mean squared current, right? So if we have the root mean current, we can do what now? We can now use this formula there up there. There we can make use of that formula that P average is simply what? Is simply I R M S times what? So it was it the voltage or what? VRMS times that. You see, VRMS. So am I recording? Okay. VRMS times IRMS. This one again, we're just gonna use the same formula. This all over change in T all over VRMS times IRMS. This is 500 all over 10, which is equals to we are looking for VRMS times that one 0.5. So this is 50 is equals to VRMS times 0.5 divided by 0.5 divided by 0.5. This rationalizes. Therefore, now VRMS is simply what? 50 divided by 0.5. This is 100 volts. So now, after finding this answer, you see there's a lot of work, guys. After finding this answer, we use this equation. So now, I'm going to use black. VRMS is simply what? V max divided by what? The square root of 2. You have this one, which is 100. You're looking for what? For V max all over the square root of 2. So cross multiplication, you have V max, which is equals to 100 multiplied by root of 2, which is equals to what? That means the square root of 2. The answer is 141.42 volts. This is the answer, is 100. Let me confirm 100 times root of 2. Yes. So that's the answer, guys. Now, they were looking for what? For the maximum peak voltage. So that's the maximum peak voltage. So now, I'm still recording. So that's the maximum peak voltage. Now, you saw how simple it is, guys. You just have to know what you're doing. Now, so now, let's take a look at the next question. I think this is the last question so that we can rest. Yo, yeah. What is this? Is called photoelectric effect. Wonderful chapter, guys, in physics. So now, photoelectric effect is all about photons, electrons ejected. You see. So now, during an experiment, light of a different frequency is radiated onto a sliver cathode of a photocell, and the corresponding maximum speed of the ejected photoelectrons are measured. The graph of the energy of the incident photons versus the square of the maximum speed of the ejected photoelectron is shown below. The graph of energy of photons versus the square of maximum speed of a photoelectrons. So now the what we have, if you're to check, remember that the energy of a photon, guys, this is the formula. The energy of a photon of incident light, this is what? This is the work function plus what? The kinetic energy, EK max. Then multiplied by what? The kinetic energy. And we can also write this like this, that what is this? That EK, not EK, this is the energy of a photon, guys. This is not electromotive force. This is energy of a photon. So now we can write this as what? We can remember EK from our motions. This is half mv squared. So we can say half mv squared, and then plus what? Plus the work function. The work function, guys, this is the minimum energy required to emit electrons from a certain metal surface. Yeah? So now this now becomes what? The M, and we can call it what? The mass of photoelectrons. Understand? So you can just put small e and say this is a photoelectron. So let me just try again a small e so that you guys can see it. So now, if you have to check, this is y is equals to mx plus c. Prove me wrong. Check the y-axis. What is the y-axis? Is the energy of a photon. What is the x-axis? Is the what? The speed. Which is what? Isn't this the speed? X-axis, isn't that the speed? So what is the gradient? The gradient is just what? The half of what? Of the mass, né? Of a photoelectron. Represent what? The mass of a photoelectron. So now let's take a look at the questions. So now the first question, I cannot forget this definition. The photoelectric effect, guys, this is very simple. This is the process whereby electrons are ejected from the metal surface when the light of a suitable frequency is incident on that surface. Can I repeat again? Okay. The process whereby the electrons are ejected from the metal surface when the light of a suitable frequency is incident on that metal surface. So what is the light of a suitable frequency? The light of a suitable frequency is known as what? The threshold frequency. The what? The threshold cut-off frequency, which is what? The FO. That's the what? The minimum frequency of light needed to what? To eject electrons from the certain metal surface. Threshold frequency. But photoelectric effect is what? The process whereby electrons are ejected from the metal surface when a light of a suitable frequency is incident on that what? Surface. Okay. Let's see for recording. Okay. So now 10.2, write down the value of the work function of a sliver. You see, write down what? The value of a work function. And something that I should have told you guys is that now guys, what is the definition of a work function? Work function, I told you that this is the minimum energy required to what? To emit electrons. Now, from what? From a metal surface. It's just the minimum energy to make the electron excited. So if the energy of a photon, which is incident to what? Again, this is what you'll find that this is what the energy of a photon in nanometer. Let's say is 6 times 10 to the power, let's say minus maybe minus 9, something like that. I'm just giving assumption. So let's say now we've shown a light into our metal. This is what? Our metal. Yeah? Let's say we shone a light into a metal like that. So now the electrons, if the what is this? If the electrons, you have electrons there in your metal, né? You have what? Your electrons in what? Your metal. So if they get too excited, they are being ejected from the metal surface, and they will move from there with what? A certain speed. They will move there with what? A certain speed. You understand? But if, remember, work function is just the minimum energy of what required to just emit electrons. But if the energy of a photon is what is equals to the work function, the electrons are not ejected. You see, they are not what? They are not ejected from the metal surface. The meaning of eject is meant to like make them leave the surface there of what? Of a metal. You see, make them to what? To leave. But if energy of a photon is equal to the work function, which is what? The minimum energy of a photon. It means now the electrons are not going to leave what? The metal surface. And if you are to check the graph here, the graph starts here. The speed, remember, if the electrons leave the metal surface, they will leave with a certain speed. But when you check here, at the time the speed is 0 there, you can see, but you have a reading for what? For your photon. It means you have what? You have 7.48 of what? Of energy shown into what? Your metal there, energy of a photon. But those electrons, they didn't what? Leave the metal surface. So it means now that the energy of a photon is what? Is equal to what? The work function. Whenever you have that case, guys, it means now that's just the minimum energy that was required just to emit electrons. You see? To what? To emit electrons. So it means now the photoelectrons are emitted onto the surface of the metal, but they don't have what? The kinetic energy. They don't have what? The kinetic energy. Of course, they are emitted onto the surface of metal, but they don't have the kinetic energy. So they don't what? Move away. So the velocity is what? Is 0 meters per second. So they don't what? Move away. So EK now becomes what? 0 joules. So they don't what? Move away. So it means now the reading, write down the value of a work function of a sleeve. It means now the reading E here at when the speed is 0 is equal to what? Is equal to the work function. So now the work function, which is the 0 naught or W naught, is simply what? 7.48. This one, you simply take that value when the speed of what? Of your electrons is what? Is 0. You see? That's what it will give you, the reading of what? Of your work function. So it means that this is 7.48. Since, remember, from that equation there, remember, if this part is 0, it means that this part will go away. So now the what is this? The energy of a photon will be equal to what? To the work function. And the work function is just the minimum energy required to emit electrons from the metal surface. Okay? So they don't have the kinetic energy, but to move, so they don't move away. So it's just that reading there. That's your work function. So that's 7.48 times 10 to the power minus 19 joules. I'm taking this value here combined with that part there. You see? So now that's the energy of a photon. So now they say write down, use the Riemann calculation. Okay, we have to use Riemann calculation. Remember that energy of a photon is equal to what? Is equal to the work function. It's equal to the work function plus what? Plus the EK max. Plus what? The EK max. So now, let me for now, let me just remove this. So now the EK max, which is equal to half mv squared. So now half into m, the speed there is 0 squared. So it means now therefore the EK max, the kinetic energy of the electrons is going to be what? 0 joules. So therefore now if that is 0 there, it cancels. So you mean you have what? E, which is equal to what? The work function. So therefore the work function, let me just read that nice. So now therefore the work function is simply what? Simply 7.48. What was that? Times 10 to the power negative 19 times 10 to the power negative 19 joules. The energy, the work function, the minimum energy required to emit electrons from the metal surface. So now I have to change color there. So now guys, they're saying what now? They're saying that which physical quantity, this is this part. So which physical quantity can be determined from the gradient? Guys, I've already explained this. Which physical quantity can be determined? The physical quantity that can be determined is what? The mass of electrons. Because the gradient represent what? This is the gradient. Let me just highlight this so that you can see. The gradient represent what? The mass of what? Your electrons. So the physical quantity that is represented there is just what? The mass of what? Of electron. So it means what? The mass of what? Of photoelectrons. Or you can simply say this is just what? A half m, meaning half of a mass electrons. Now, so it represents the mass of a photoelectrons there. So now, yeah, I'm tired. Am I recording? Okay. So now 10.4, guys, calculate the value of x as shown in what? In the, or as shown on the graph. So we have to calculate that value as shown on the graph. So now that's very simple, guys. Remember that since we can use, remember we know that the gradient is simply what? A half me. What is this me? Me is simply what? The mass of what? Of our electron. And I'm going to show you how to, where you are going to find that value there. So I'm just going to use the gradient formula to determine the value of x. So you approach this doing like this. We know that the gradient is simply what? Change in y all over change in x. What is change in y? Change in y, this will be our y2 minus y1. This will be our x2. This is what? Our x1. So it means that's 11 point what? 0.98. Né? So 11.98 times 10 to the power minus 19. Let me make sure I got that right. 11.98 times 10 to the power negative 9. And then subtract 7.48 times 10 to the power negative 19. All over x1, that's, so that's x minus x2. X2, remember, this is changing y all over changing x, guys. This is what? Y2 minus y1 all over x2 minus x1. So now this is y2. You start with the higher value, lower value, higher value, lower value. So that's 0 there. Yeah? The lower value is 0, x1 there. You saw that? Okay. So now this one, the gradient represents what? The half m of what? Of electron. I'm going to show you how do you get that value. So let's keep this 11.98 times 10 to the power minus 19 minus 7.48 times 10 to the power minus 19 all over x minus 0. We know that's x. Yeah? So now this is going to be a half into the mass of electron. Let me show you where. So now let me show you where. This is the mass of electrons. So if you have to check here, guys, you see this part here. Let me highlight. You see this part here. This is what? The mass of electron, which is what? The 9.11 times 10 to the power negative 31. Is what? It's 9.11 times 10 to the power negative 31. 9 times 10 to the power negative 31. So that's 9.11 times 10 to the power negative 31. Did I got right? Correct? Did I get that correct? Did I get it correct, guys? This is 9.11, 9.11.10. So, okay. We don't want to make silly mistakes. So now let me deal with the top part. Né? So this is 11. 11 minus the numerator, 11.98 times 10 to the power negative 19 minus 7.48 times 10 to the power negative 19. So the answer, hey, let me make sure that this is not in scientific. 11.98 times 10 to the power minus 19 minus 7.48 times 10 to the power minus 19. So the answer that I have is 4.5 times 10 to the power minus 19 all over x. So now let me punch this value, a half of 19.11. Guys, please help me by subscribing. Yo, guys, if you don't subscribe, now I'm not helping you guys. Yeah, I just focus on myself. Or left, those who will subscribe, those who come directly to me and say, sir, help us. Help us, say. Of course, now I'm doing it for free, guys. I'm doing it for free. Of course, this app that I'm using here, I'm paying to tutor, you see, but I don't worry about that since I just want to help you guys. Ne? I won't do it for money. I'll help you guys. Time for money will come. Ne? But for now, enjoy free lessons. You see? Enjoy free lessons, guys. So please help me by subscribing and drop a simple comment just by saying what? Thank you, sir. You see, it will help, guys. It will really help me. Even though I don't even know you, or we have never met, or you have never seen me, it will really help. You see, a thank you from a stranger, guys. Ne? Uh, it's a medicine. Trust me. Ne? It's a medicine. So simply drop a simple comment just to say thank you, guys. Ne? So simple comment, guys. God will help you. I'm telling you the truth. My faith is stronger than my math skills. Without God, I'm nothing. Ne? Yeah, you should trust also in God. Have faith in Him. Right? This is not time to play, guys. Ne? You have to, like, when you're studying, make sure that you always include Him before you can even study. Before you can even like greet your friends, greet your loved ones. Always thank God for a wonderful day. Even though you had a bad day, guys. Ne? Even though your day is bad and something like that, always give thanks to God, because once you start giving thanks to God, God is not like man, you know that. Ne? You'll be so amazed. This person doesn't is like he or she's not focusing on like the mess she's in, and or how the life is going and stuff. So the more you give thanks to God, the more He blesses you. You see, but if you are that one person who always ask God for any, God, I need money. God, I need this. Now, God doesn't work like that, guys. If you praise God, God will give you all these riches. You see, that's why it says the kingdom of God comes first. No? And everything shall what? Follow you. So you praise God, God will help you. So when you are studying, guys, when you are studying this physics, how I'm telling you, always pray, Corey. God, please, may I understand why what I'm being taught here, so that I can go there with confidence. You see? Because what I'm teaching you now is the secret, guys. Yeah? To unlock the treasure that you'll receive when you sit down for your, what is this, for your final exam. No, so I won't say much. So I'm just saying, always pray and trust in God, guys. If even if you're a non-believer, always know that God exists. Don't hear those people say what thick pastor and stuff. Guys, focus on yourself. Know God for yourself. Know Jesus for yourself. This is, you see, salvation is personal, né? Know Jesus for what? For yourself, for your own benefit. Don't say now the world is corrupted, it's full of fake pastors and stuff. They're preaching what. When not know Jesus for yourself. Yeah? Make sure that you make that for your own benefit. I'm trying to find this value here, since remember that x here represents what? The speed. So it means now we have what? We're just going to multiply this value by 10 to the 10 to what? uh Again, this is gonna be 10 times so 12. Let me just go back there. And then what? Meters. Is it meters squared or meters squared per second? Eh? So this is at the unit. Let me see if I include that 10 times 10 to the power. I'm so tired, guys. So now this is what you will have here. So therefore, the final answer is x, which is close to 9 point what is this, 9.88. I'm rounding to two decimal places. times 10 to the power 23 m squared, and then 2 that. This is what the unit that I got there. So make sure, guys, after getting your answer, our answer is just here. The part going to the right there, we went to what was that? We went to the graph and read that thing. Okay, if we can find, let's say 10, we need to multiply this by what? By 10 to that thing there. Understand? I'm so tired. Or you can just leave it here. Just multiply like that. You won't go wrong, guys. So this is it, guys. Now, so now let's take a look at those last questions so that we wrap this up. So yeah. So remember, I promised that before Monday I will share a full lessons for your preparation. And you guys, you have to subscribe to make sure that this guy, we have to like let's help him reach what those, let's make the let's keep the subscribers up, you see, so that I can keep more providing or keep on showing up, guys, for you guys. Even myself, I'm writing like on Tuesday, I'm writing on the 10th. I have reports, I have assignment, I have projects, you see, but I still have to show up here and teach you guys, everyone. So you see, I've been doing this for like close to 5 hours, but yeah, I'm not blaming myself for tutoring you guys. I'm helping you guys. So now, let's see, how will each of the following be affected? Choose from increase, decrease, or remain the same. Don't forget Proverbs 13, guys. Don't forget what? Proverbs 13. I'll tell you about Proverbs 13 after this. How will each of the following be affected? Choose, increase, decrease. The gradient, guys. They're saying what? Oh, the experiment above is now repeated using the light of higher intensity. Guys, when you increase intensity, it has no effect on what? It has no effect. Hear me well. It has no effect on the kinetic energy. It has no effect on the work function. It has no effect on what? On what is this? The gradient. Understand? The gradient, remember, is what you have to find it here. EK part there. So it means now the gradient remains what? Remains the same. Intensity guys just affect what? The number of electrons ejected per unit time. Understand? So they get more excited. So now, what happened to the number of photoelectron emitters? They increases. Because now, when you increase intensity, it increases what? The number of photoelectrons ejected per unit time, and thus increases what? The current. You see, so you have what? You have that intensity, and then you have what? Those electrons in a metal surface like that. You see, so if you increase intensity, when you increase the light of intensity, then you're increasing what? The light of intensity. So more photons what? Strikes what? More photons strikes what? The surface. Then more what? More photons strikes what? The surface of what? Of the metal. This energy of a photon that is going to come here. If the energy of a photon is greater than the work function, the electrons are going to be what? Ejected. And if the energy of a photon is greater than what? The energy of a what? Of the electrons. The electrons are going to be what? Are going to be ejected, because now when the energy of a photoelectron strikes the metal surface, now the electrons what? Are ejected, and they will move there with a certain speed there called v. They'll move there with what? They will rise with a certain speed v. So if the energy of a photon is less than the energy of what? Of electrons there, now your electrons won't be able to be what to be ejected, because remember one thing: when the energy arrives or strikes the metal surface, now the energy of a photon is converted into what, or is transferred into what, into the energy of what, or is transferred into what, into electrons, or energy of electrons. So you have to, like, you bring, is this guy here brings energy to this guy, so that this guy, when he has enough energy, it can be what, it can be ejected. You see, it can be what, excited and go like that up, understand, with a certain speed, what, ek there, with a certain, or you can say that, with a certain speed ek there, or they will have enough energy, let's say like 19 joules, they will have enough energy to what, move from the metal surface, when the energy of a photoelectron is enough, then, so that it can be transferred to that metal, or to that energy of electrons, so that it can rises or leave the metal surface. So the number of electron increases as you increase the intensity, because now there will be more collision per unit time. It's like, do you know rate of reaction, guys? The rate of reaction says that when you have you have what, you have, let's say you have in or this is the volume, né? Let's say that you have particles inside the container like that, né? In particles inside the container like that. The more you increase those particles, there'll be what, there'll be collision, or the more you increase the rate of reaction, the particles inside that thing, what does, increases, they collide more frequently. Understand? They collide what, more frequently. I don't know if you understand, but I hope that you understand. Do you know a catalyst? The catalyst is the one that speeds up the rate of reaction. So once you add a catalyst to a reaction, you are increasing what? You are increasing the rates of what? Of reaction. You're increasing what? The rates of what? Of your reaction there. You're increasing what? The rate of your reaction. So once you increase the rate of your reaction, there is what? More collision per what? Per unit time. So now there is more collisions per unit time, because the photoelectrons, or the photon strike the metal surface, and there is what? Collision per unit time, which what, this collision is caused by what? By the increase in the number of what, of this what, photoelectrons. So more electrons are what, are ejected per unit time, and we are done, guys. That's it. And you have for that 150. Here is your 150, guys. I'm giving it freely. I'm tired, guys. Please subscribe. I'm Boni, guys. By the way, I'm what? I'm Boni. Boni. That's my name, guys. Boni, or Boni. That's my name. So subscribe. For oh, I need 100 subscribers, above 100, guys. That's not my aim to get 100. I need more than 100 subscribers, guys. Yeah. So thank you for watching, guys, and I will see you guys next time. And that will be it for today. Yeah, we are done with everything, and I can reverse back, so that you see, guys, that yes, we were working here. You see. So that would be it, guys.